particularly in the developing countries. However, the conservation of limited fossil fuel supply, climate change, and concern over global warming have prompted the use of more and more renewable energy sources. Therefore, a number of initiatives are currently being undertaken by different countries for the implementation of renewable energy based clean cooking systems. Now, LPG is popularized as the most popular clean cooking alternative to replace the traditional biomass, coal, or kerosene based cooking. However, LPG is a fossil fuel, as we all know, derived from the energy source, and it produces CO2, thus causing global warming. Hence, this climate change may reverse the development gains in the recent decades. Therefore, the development of solar energy based cooking system may help to achieve the Sustainable Development Goal 7, which aims to ensure access to affordable, reliable, sustainable, and modern energy for all. In today's event, we have lectures lined up by experts from eminent academic institutions like IIT Delhi, IIIT Naya Raipur, prominent industries like GAIL, Finovista, who will be sharing their views on the current status of solar energy based cooking technology and the possible future scope of research in this domain. Along with them, we also have talk by researchers from our own institution, CSIR CMERI, who have immense expertise of working in this field. Before proceeding any further, I would like to request Dr. Partha Bhattacharjee, our Chief Scientist, CSIR CMERI, Head Information and Technology Group, and the Institute in charge of CSIR CMERI, to share a few words with us and to illuminate on the current status of research in this domain and for paving the future roadmap. So, over to you.
Sir, you are not audible, sir.
Please unmute. Sir, please unmute.
Sir, you're muted. Yeah, now it's okay.
Am I audible now?
Yes, sir. Yes, sir.
Oh, this headphone is creating problem. Okay, it's okay now, right?
Yes, sir. It's fine.
Okay. So, very good afternoon to all of you. It's a nice event. It's a pleasure to invite all of you for this wonderful event. Now, all of us, all over the world and also in the country, we are aware that there is a lot of carbon emission and the global warming and the crisis of traditional energy is becoming a pressing problem. So now, as for the economists and the all entire world, it is understood that India is going to be the next manufacturing hub of the world. Everybody is saying that coming decade is for India. So what are the lessons we should learn from the other emerging economies or the Southeast Asia, other countries? We are lucky to understand and learn the facts, the consequences of having scaling up manufacturing and supplying to the entire world. What are the consequences in terms of energy crisis, carbon emission, climate change, and a lot of issues are related to this around this energy issues. So now, if you look at the situation, there is no uh, quick solution for changing this, transforming this traditional energy to renewable energy and green energy. So what we must do is incremental changes, small changes, and go on compounding on it year, month on month and year on year basis, and take a stock of the situation, where we stand. So after 5 years from now, we should start our mathematics, our calculations right now. So only then we'll understand 5 years from now or 10 years from now where we'll stand. Uh, so for this, one needs to start the exercise. Okay, I know a number of industries, they are transforming to green energy or renewable energy, and in the manufacturing, from the manufacturing stage itself, they're transforming themselves and reconfiguring themselves for renewable energy as much as possible. I know Tata Steel is setting up a manufacturing plant with usage of solar energy and other renewable form of energies. There are a number of industry experts from industry and academia in this panel. I'm sure they'll be better equipped with the data, how much energy needs to be produced in the coming future. So I will listen to them. And in CMERI, for domestic usage of electricity, we have taken a certain drives. You have made a solar PV energy-based electric cooking system, then hybrid solar and biogas cooking system, and solar-assisted improved biomass cooking systems. And we have also transferred the technologies to a number of MSMEs. And we want to spread this message to every household and different part of the country, that we are able to, whatever small amount of incremental effort we can give, and transform whatever amount of energy for domestic usage to renewable and non-traditional energy. And we should encourage that and propagate that message through this iConnect event. So I welcome again all the participants, and it will be I can see a number of very eminent speakers are there. They have great expertise in their respective fields. So I'm sure it will be a very exciting event. I wish a very good luck for the all the participants. With this, I hand over to the convener. Thank you.
Thank you, sir. Thank you for your encouraging words and thank you for gracing the occasion. So, with this, we will be starting with today's presentations. The first presentation is of Dr. Ravi Kumar from IIT Delhi. Before he starts his presentation, I would like to share a brief biography of Dr. Ravi Kumar. Dr. K. Ravi Kumar received his PhD from IIT Madras in 2012. At IIT Madras, he worked on the investigation of energy efficient receiver for line focus concentrating solar power systems such as parabolic trough collector and linear Fresnel collector for process heating and power generation applications. He also worked on solar field design, feasibility study of large-scale CSP plants, and multi-stage solar desalination systems. After his PhD, he worked as a postdoctoral fellow at ABB Corporate Research Center, Bangalore for a year. Then he joined as an associate scientist in the same organization in July 2013 and got promoted as scientist in 2014. His research work at ABB Corporate Research Center includes solar aided thermal power generation, solar heat for process heating applications, and multi physics modeling of secondary steel making process and measurement devices. Since November 2016, he has been a part of the Department of Energy Science and Engineering, IIT Delhi, as an assistant professor. He has authored several papers in reputed peer reviewed journals and has several patents filed and granted in his name. He has also been an avid speaker in many international conferences. Dr. Ravi Kumar's research is focused on design and development of efficient and cost-effective solar thermal power systems for various applications like desalination, process heating, power generation, and so on. He also focused on development of thermal energy storage technologies for medium and high temperature applications. With this, I would request Dr. Ravi Kumar to start his presentation and we'd be looking forward to hear from him, sir.
Sure. Thank you, Dr. Sarkar, for the nice introduction. Could you able to see my screen?
Yes, your screen is visible.
Okay. Sure. First of all, I would like to thank Dr. Chanchan Loha and CSR for this opportunity. So in this session, I'll be talking about current status of solar cooking and research progress and challenges. So the solar energy is essential. We all of us we know that solar energy is essential. Uh, Solar energy is essential to bring down the greenhouse gas emission as well as household air pollution due to the conventional cooking. So I have organized this presentation in the following manner. So first, initially we'll discuss about why solar cooking is essential and what are the technologies based on solar thermal it exists in the market. So there are three technologies exist in the market. One is box type solar cooker, panel type solar cooker, concentrating solar cooker. There are many limitations in these technologies, and let us discuss what are the limitations in these above mentioned technologies. Then also people have developed, researchers have developed indirect solar cooking, and then with thermal energy storage as well. Then we'll discuss about what are the challenges exist in current solar thermal cooking technologies. Then also we'll discuss about what are the recent advancement in this field. Then I'll talk about maybe a few case studies where the commercial community level solar thermal technology implemented for cooking for large scale application community level cooking. That maybe a few case studies I'll share, and then I'll summarize the presentation. As mentioned earlier, so 1/3 of the global population, approximately around 2.4 billion of people across the world, they suffer. I'm sorry. They suffer. Still, they use conventional fuel for cooking, mean that they do not have the clean fuel for cooking of the food. Each year, approximately around 4 billion people die prematurely from illness attributable to household air pollution. So, in case still, if we depend on the solid fuels for cooking, and in 2047, almost the greenhouse gas emission will increase by around 24%. So what are the solution? So we should move towards the green, the green energy. So particularly solar energy for cooking of to meet the cooking energy demand. Using solar energy for cooking can resolve all these problems in an eco-friendly manner. Typically, if you look at in India, in most of the locations, we receive solar radiation approximately between 4 to 7 kilowatt hour per meter square per day global radiation. So if you look at what's the current status of solar cooking in India, approximately around 6 lakh Bosch type solar cookers are installed across the country, and around 6,000 paraboloid dish collector, solar dish collector, and circular dish collector for community cooking. But the status is, we are not sure the current status whether it's working or not, but at least we have the deployment relatively in higher side. Yeah, if you look at the global status, so in the global status from low and middle income countries, so people use various fuels to meet the cooking energy demand. So typically people use around 49% of people use gas as the source, and around 37% people use biomass to meet the cooking energy demand, and around 7% people use electricity, and then 4% and 2% respectively for charcoal and coal, and around 1% people use kerosene to meet the cooking energy demand. So the solar energy cooking can be classified broadly. We can use solar thermal technologies as well as solar PV technologies. Here I'll be focusing on solar thermal technologies. In the next session, Dr. Chanchan Loha will be talking about solar PV cooking. So typically in the earlier days, we have three predominant technologies used for cooking of solar thermal technologies for cooking of to meet the cooking energy demand. So the first one is box type solar cooker, and then panel type solar cooker, and concentrating solar cooker. So typically in the box type solar cooker, so it has the wooden box and then covered with the glazing, double glazing, in order to minimize the convective heat loss, and also will have a booster mirrors. The booster mirrors, so that depends on the design. It may have one booster mirror or also people have tried with multiple booster mirror as well. So these booster mirrors can be adjusted with respect to time, so that it could able to reflect the solar radiation falling on the box on the cooking vessels. So coming to the panel type solar cooker, so here the panel, the array of reflectors are placed surrounding the cooking vessel and it reflects the solar radiation onto the cooking vessel. But here this cooking vessel is technology is mainly used for in summer where you can hit higher insolation. But whereas during windy days or where we have low sunshine, it takes predominantly longer time to cook the food materials. And also it is one of the inexpensive technology to utilize the solar energy for cooking. Another interesting technology is concentrating solar power. So concentrating solar technology, people use paraboloid disc collector or circular disc collector for cooking of food. So here it can have either single facet or can have a multi-facet reflector. It focuses all the solar radiation on a focal point where we can keep the cooking utensil, and all the solar radiation falling on the aperture of the concentrator focus on the focal point where we could able to heat the food material presented in the focal point. But this kind of technology requires continuous tracking since it's a concentrating technology. Always aperture of the collector has to focus or kept normal to the solar radiation. So this technology requires the continuous tracking or adjustment of the concentrator. And due to that, since this technology can be placed only on the outside of the house, so mean that outside the kitchen, so one has to stand under the sun if you want to prepare the food. And then there are many studies happen across the world in order to analyze the performance of the box shaped solar cooker. Even in our department, our former professor, Professor Malik, and his team, he has investigated how we could standardize the performance of the box shaped solar cooker. So he has come up with the two kind of formulation. One is first figure of merit, the F1, and here he has performed the studies without any load, cooking load. He has studied this stagnation condition, and based on that he has arrived what is the value of F1, the first figure of merit. And then also he performed with the cooking load and he calculated what is the second figure of merit also he has calculated. And based on this, one could able to standardize or test the performance of the box shaped solar cooker. And also various literature talks about how we could able to calculate how much amount of energy required for cooking. So the cooking power can be defined between the mass of the food to be cooked and the specific heat of the food material, and then how much temperature you have to rise by. Typically they mentioned that typically it meant for around 10 minutes. So that's how the 600 they meant for. And standard cooking power, in case if you want to compare at different location, because the insulation keep changes with respect to location, and they mentioned that the cooking power into 700 by the solar insulation. So this gives the how much temperature difference we could able to achieve in any solar cooker. And also people have come up with the formulation for what is the energy efficiency, the exergy efficiency of the solar cooker. So this is a formulation people use to calculate the energy and the exergy efficiency of the solar cooker. And if you compare the efficiency of the various cooking device, so if you look at in the solar thermal, concentrating solar cooker, we could able to get close to around 60% of the efficiency. And then box type solar cooker with fin pot, we could able to get around 50%. Panel type cookers around 42%. Box type and other panel type cookers between varies from around 20 to 30%. Whereas if you use maybe induction stove or if you use electricity fuel, we could able to get close to 90% cooking efficiency. And LPG stove, we could able to get 60%. And if you use kerosene around 40%. Wood, it's very relatively poor, will get around 25 to 30%. And what are the limitations of the existing solar cooking technology? I mean that the box type or panel type or concentrating solar cooker. In the box type solar cooker, we could able to achieve maximum 120 to 140 degrees centigrade, and then again we may not in a position to cook all kind of foods. So mean that one is low operating temperature, it's a slow cooking, and one day we could able to cook on the outside. Mean that we cannot able to cook inside the house. And the panel type cooker, higher heat losses and very sensitive to the wind. In case there is more wind, then the more converted heat loss, and then low efficiency, the performance is very poor, and also it operates only very low temperature, and again it could able to operate on the on-sun cooking. Concentrating solar technology, so it's a bulky, maybe you need relatively more space, means that if you want to put up the concentrator, and then it also expensive, since in case even if you're manually tracking is fine, otherwise if you are to fabricate the curved reflector or parabolic reflector, it's relatively expensive. And then safety issues, because when you want to make the boiling the food or frying the food, you are also exposed to under the concentrated solar radiation. And then also this also meant for in olden days it's a onsen cooking. But in recent days, yes, people have tried to focus onto the storage medium or inside the kitchen and still trying to make it. But still, we have a technology in order to cook all kind of food which we would like to have it. Mean that starting from baking and then frying and boiling, all kind of cooking we cannot in a position to cook in any given technologies. So obviously box type and panel type may not be efficient. So in the right choice, if you want to cook all kind of foods, then maybe yes, if you want to make chapati or other things, we need temperature 220 degrees centigrade plus. So then only option is we have to go for concentrating solar thermal technologies. And typically this can be classified into direct solar cookers and indirect solar cookers. So direct solar cookers, we can say that either it can be a moving focus, mean that the concentrator and the receiver both can move together, or we can have a mean that we can have a paraboloid disc collector. And then if you want to, the other technologies, fixed focus, mean that we can use a safer disc collector, and then only the concentrator moves, and we could able to concentrate the solar dish on a particular focal point. And coming to indirect solar cooker, and again here we can have a either fixed focus or also, we can have a Fresnel reflector based reflector, or we can have a parabolic trough collector or parabolic disc collector. Means that any kind of concentrator we could able to use it. But thing is, if you want to minimize the intermittency of the solar radiation, obviously we should go with energy storage. Without energy storage, if you want to prepare the food at any point of time, it's not possible. Means that if you want to prepare, then only you could able to prepare only the meal, midday meal. But still, if there is a cloudy, sudden cloudy, we will not be in a position to cook it. So then obviously the energy storage is one of the important aspect. We have to integrate with the existing the cooking technology. Then only we could able to cook food at any point of given time. So the current status of constant technologies, there are 4 technologies, mean that I would say 3 technologies available in the commercially. The first one is we call as the focus is moving along with, mean that the technology, the cooker also moves along with the concentrator. So there are 2 technology. One is escape type or prince type. So this technology can be meant for preparing food around from 10 to 40 people. And the escape type, the aperture is in this form of circular form, and whereas the prince type, it is in the square. If you look at the top aperture, it's on the square form. So both are paraboloid disc collector. And then moving to the next one is cephalid disc collector. So cephalid disc collector, only the concentrator moves and then it concentrates solar radiation onto the fixed focal point, whereas where we can keep the cooking utensils and we could able to prepare the food, or we can generate the high temperature fluid, and that high temperature fluid can be used for prepare the food. And similarly, iron disc collector also can be used for preparing the food. Sorry. And if you look at the specification of the paraboloid cooker, it can be either circular or it can be a circular or the square. And then the range of aperture varies from 1.4 meter square to 7 meter square. And then it's a direct cooking, meant for direct cooking. And the capacity one could able to prepare meal for 10 to 50 people. And then mostly people have tried for the boiling, not the other application. And location of the utensils, you have to stand under the sun and you have to prepare. And then if you talk about the cost per meter square, around it costs you between 6,000 to 7,000 per meter square of the collector area. And then the operational maintenance is relatively easy and then constrained. So here this technology can be moved with respect to the location, and then even unskilled could able to operate this technology. The flexibility in cooking period mean that at least we should have minimum day and night, because all these concentrating solar cooker, it works only on the based on the beam component. We need something between 400 to 500 watt per meter square day and night. And then moving to direct cephalid disc collector. So typically it consists of 2 reflectors. So there's a primary reflector is on the cephalid disc collector, and then it concentrates solar radiation onto the secondary reflector, whereas it's kept on the kitchen, and then the secondary reflector focus the concentrate the further solar radiation onto the cooking pot. So here the advantage is we could even prepare the food at the kitchen, but people have tried for all kinds of preparing food, but still they are not successful in preparing all kinds of foods using the cephalid disc collector as well in the direct method. And so one of the drawback is cephalid discs have higher cosine losses. The overall performance as compared to the paraboloid disc collector is relatively less. And then if you look at the aperture, looks like elliptical in aperture, and the range of aperture varies from 7 to 16 meters per area. And then so cephalad disc cutter, so the fixed focus, so it can direct contact. And then the capacity, that depends on the people. So you could have multiple cephalad disc cutter, and you could able to focus, or you could able to collect the heat, and we can use the heat for preparing the food. And most of the application where they installed, there are commercially still there are many installation. It's currently working, and most of them are the people are using boiling of rice or preparing the dal. And then so it's not necessarily you have to prepare the food on the outside the sun. Even you could able to prepare the under the kitchen as well. A typical cost requirement, since it requires one axis tracking system, it is relatively expensive as compared to the paraboloid disc cutter with manual tracking. It costs around between 14,000 to 16,000 per meter square area, and it requires relatively some maintenance since it involves all tracking other things. In case we don't do proper tracking, and then the placement of the concentrator on the position, so we may not in a position to focus all the solar addition onto the cooking vessel. And then it takes at least some semi-skilled labor, and then the manufacturing process relatively some level of difficulties involved. And then indirect level cooking, so we can have like we can have a multiple cephalad disc cutter, or even in that case we can have any constant salt technology. We can collect the high temperature fluid either in the form of oil, or we can use steam, and that can be used stored in the storage tank. And then we could able to supply we can use the pump and to pump the fluid, and it can goes to the cooking vessel, and we could able to prepare the food. And there are many installation. It's people have installed the cephalad dish or parabolic dish cutter in order to collect the heat energy from the solar field. Or even as I mentioned that any solar concentrating technology can be used to collect the heat. So being that here we would like to have, if you want to prepare any kind of foods, so we need something like 200 plus degrees centigrade. Or even if you want to prepare the dal and meal, so we need at least 150 degree centigrade. And then when you're comparing the specification, it can be any kind of concentrator, and the range of apertures, it depends on the application, what kind of technology you're going to use, and so along accordingly then one has to choose the aperture area. And then typically it is, since it is indirect mode, will produce the hot oil or steam, and the steam can be used for the cooking. So the capacity, so yeah, even one can think about even small scale community level to even the large scale application also we can think about it. And typically people try for even other application, but it's successful for mainly boiling. And then the location is away from the concentrator, mean that you can collect the steam, and then you can use the steam inside the kitchen. And then it requires, since it needs additional system components, I mean the storage system, controls, from all such things, it's relatively expensive. Per square meter of the solar collector, it costs around 16,000 to 20,000 rupees. And then operational maintenance, it needs maybe proper maintenance, and then also it requires at least semi-skilled or skilled labor it requires in order to handle it. What are the challenges involved in the solar cooking? It's in generic, either it's a box type solar cooker or constant solar cooker. The cooking can be done only during the sunshine, right? In case we don't have a storage, any storage, only during the sunshine duration we could able to do it. And that too, in olden days people prepare under the sun, which is not at all convenient. Even these days, in the modern days, if you want to ask someone to go and cook for an hour and under the sun, no one is going to prefer. Even if it is inexpensive, the fuel, there is no fuel cost, but no one is going to prefer. The possibilities of incompatibility with traditional cooking practice mean that the thing is you have to take all the kitchen items, mean that whatever the ingredients you want, you have to take it from the kitchen, and then you have to stand under the sun, you have to prepare, which is not at all desirable. Operational complexity means that if you want to operate concentrated cooker, then you have to keep tracking the concentrator so that it always focus on the solar addition onto the cooking vessel. The most of the existing solar cooker do not facilitate indoor, means that the cephalad disc cutter and then indirect type will facilitate indoor cooking, but even those technology facilitate only boiling, not preparing the dosa, idli, chapati, all such kind of food, or frying. So all kind of food it does not facilitate. So risk of, in case we are operating under the sun, so there's a possibility of you are exposed to constant radiation, you may get damaged. And then concentrating solar cookers need frequent assessment, means that it requires tracking, it requires Since now these days the LPG price is increasing, but still if you compare with the capex of the solar technology, so still there is an inexpensive solution is available. So the need of thermal energy storage means that if you want to prepare food in the early in the morning or late in the night, so then definitely we need thermal energy storage, or even in the daytime also we need storage. And cost could be deterrent for low income families, and then it needs special attention for developing the technology. And then still many people are not aware of how we can utilize solar energy for cooking. And what are the advancement happening in the whatever I mentioned, the technology, box type or panel type or concentrating solar thermometer? What are the advancement? So people have tried. So the box type, in case if you have only one box, you are limited, and then you have to wait under longer time for preparing the food. People tried multiple box type solar cookers together so that you could able to prepare multiple foods at the same time. People have tried having the concentrating reflector on the bottom of the box type solar cooker, and then integrated with the box type solar cooker. People have tried with, instead of one reflector, they'll have multiple reflectors. They tried, and then also the people have tried with multiple reflectors as well as parabolic reflecting surface. People have all kind of possible combination tried in order to increase the temperature or the flux available on the cooking vessel. People have tried. On the panel type solar cooker also people tried panels in that it attaches a kind of concentrator, and then so that also we could able to minimize the wind losses, the heat losses due to the wind, and also different shape of the parabolic shape, or you can have a multiple reflector shape. So people have tried, but still these are not very successful. And as I mentioned that the storage is inevitable. It's really needed for the, if you want to achieve solar cooking, if you want to take into the market without energy storage, it's really difficult to meet the energy demand for cooking. I mean that if you want to prepare food at any point of time. So typically one can choose either sensible heating or latent heat storage heating. The sensible heating you can use either the liquid oils, or you can use a solid medium so that you could able to extract heat energy. But the issue is if you want to achieve the constant temperature with this period of time, it will be questionable. It requires some special design in order to achieve the uniform temperature at a given point of time. The latent heat storage system, yes, we could able to go for it, but it may be relatively expensive. And at least for low and medium temperature, at least low temperature is already commercially available, and medium temperature, at least some installation already happen in the commercially. So what are the advances happening in the indoor cooking? So mean that indirect cooking methodology. So people have tried at different research organization. People have tried. So they have a solar collecting technologies. They separate the oil, collect the heat, and then separate into the cooking vessels. And also people have integrated with the thermal energy storage, latent heat based thermal energy storage system as well. And it collects the heat. It charges the thermal energy storage to the daytime, and whenever you want to prepare the food, on the simultaneous charging and discharging also happens. And here people have tried the forced circulation system. People have tried the oil to collect the heat from the receiver of the concentrating collector, and then goes into the cooking vessel, and then it exchanges the heat with the cooking vessels, and then it comes back. So this is one such installation in NIT Kurukshetra. So people have tried the solar cooking technology with ETC, and they collect the heat, and then there's a flexible steel bellows. It goes into the cooking vessel. It in the annular space gives the heat and comes out, and then so people prepare the food. And so, and also people have there are many studies. Due to the time limitation, I'm not covering all these studies. Also people have tried to integrate with the thermal energy storage, and then in the daytime, instead of having a cooking vessel, you have a thermal energy storage system, and then charge the thermal energy storage system in the daytime, and then you can take it out to the kitchen and you can prepare it. But the drawback is, if I want to prepare for different types of food, say for boiling of milk, I need temperature only around 120 degrees centigrade. If I want to prepare the chapati, I need 220 degree plus. Or if I want to frying the some vegetables, it needs altogether different temperature. So controlling of the temperature is still questionable. And then if I want to in the LPG, in case always when we are making the cooking, we will do multiple tasks together. Sometime we'll keep in the full flame, sometime we'll keep in the low flame in the same, and then we prepare the food. All kind of these things right now we don't have in the existing solar thermal cooking technologies. So let us see what are the current installation case studies. So there are community level solar cooking, though I mentioned that there are 6 box solar cooker. We don't have data whether it's currently operating or it's in ideal. But at least there are in community level cooking. There are some installations still they are working. Some few installation. One such installation is, see, people have installed Sheffler disc cutter in Sai Baba temple in Shirdi, Maharashtra. So they installed in 2009. So they installed around 40 Sheffler disc concentrator. Each concentrator aperture area is around 16 square meter area. So they're preparing around 25,000 meals per day, and then they're producing steam at 8 kg per centimeter square, and then at least they operate 300 days in a year, and then they could able to save something like around 2,000 kgs of LPG per day. And another such installation is Santivan in Brahma Kumaris in Mount Abu. And this installation happened in 1999. And then the number of concentrator here, they use 84, and each separate dish is around 9.2 square meter square. And the number of meals they prepare is around 10,000 meals they prepare. They mean that they use the rice, they also the grains, and also they use vegetables for preparing the food materials. And then the steam they generate around 6 to 8 meters kg per centimeter square, and then around 280 days they operate this Scheffler disc cutter, and then they are replacing. Earlier they used to have diesel, now almost they are saving around in annually 1,40,000 liters of diesel they could able to save it. The another installation is in the Jawaharlal Navodaya Vidyalaya in Leh. So they installed in 2011, and they installed 5 concentrator. Each concentrator is 16 square meter area. The separate type of concentrator they use, and then they prepare around 500 meals. That's what they mentioned, and they produce around 11 kg per centimeter square. This also they operate around 300 days in a year. Fine. So maybe Mr. Vimal is going to talk about the potential or the opportunities in solar cooking. But just let me give an idea. Mean that someone, if we have technology which we could able to meet to prepare all kind of cooking, all kind of foods, and if you could able to prepare the food at any point of time, then we have huge business in this domain. So even if you look at here, some of the community level cooking I will listed. So even if you prepare for the government schools, if you prepare for midday meal, we have the number of entities. If you look about around 11,50,000 entities there, and then how many number of expected beneficiaries that per day in terms of million, around 102 millions per day people get benefited, on how much amount of fuel savings and expected LPG savings given here. So similarly, you can have target the residential school, the students' hostels for higher studies, in the prisons. We can use working women's hostels and religious or spiritual centers, hotel and restaurant. There are wherever you want to cook, or even if you have your technology for household cooking, for the domestic level cooking, even you can talk about all the each and every house people can think about. They can have your cooking technology. So here just I listed how much typically energy requirement per person per day. We need around 1.7 to 2.7 megajoules of heat energy per person per day. And then maybe if you want to convert how much efficiency also things, what should be the solar corrected area, you can have a quick calculation. So this is the calorific value of the LPG, and typical cook stove it operates between 55 to 60% efficiency. So what are the pathways to go for to succeed in solar cooking technology? So we still have design optimization. I mean that the technology in a position to provide the sufficient energy, and again the technology should be in a position to cook food at any point of time, and also we should have all user convenience. So determine the most efficient and economical design, so that the cost also should be one of the factor. In case the capex even very high, then no one is going to bother about the solar cooking technologies. Second thing is even the visual appearance, how we could able to make the better design, so that the cooking technology, mean that if you look at in the direct type solar cooking, if you want to put the cooking pot on the concentrator, if you want to apply black paint, and even we don't feel that having food from there, right? So we should have something like some special design which have eye pleasing design, so that we could able to promote the technology very easily. And also we can have, even if you're talking about for the indirect type and cooking type, we need pump and other things. Then obviously we need electricity. In case if you're talking about somewhere in the remote location, without electricity also we cannot able to operate this kind of cooking technology. We need even to operate the pump or tracking of the solar collector, all such things. So in such case, obviously then you have to integrate with the other renewable energy technology, solar PV, or definitely it needs energy storage technology. And then if you want to take this product to the commercial, we should have a versatile solar cooking system. The mean that the technology, it should be in a position to cook any kind of food and then at any point of time. So that's what, and again, without changing the user, the cooking practices. Mean that if you want to use in the kitchen only for all 3 times, you should provide a technology. If you say that I will provide technology only for preparing the meantime for meal for the mid noon and morning and evening, you have to use conventional fuels, no one is source interest because keep changing the items, keep changing the cooking products. It's all really difficult. And again, this generation, most of them, they go for the job and no one will stay at home. Means that no one will prepare the food in the noon time. They'll prepare either in the before sunrise or after the sunset. So we are also working. Recently, we started working our research group on the to come up with the versatile solar cooking. We got recently project from 1 year before with the DST. We are developing a versatile solar cooking system for domestic application as well as the community level application. So right now we are in very early stage. We are developing the system. We have some numerical modeling, but still those results are not published and not very well matured. It takes some more time to showcase our outcomes. So in this, what we are targeting is, so we can have a system. You know to change the cooking vessels, and then you can cook the food all 3 times inside the kitchen, and you could able to play with the rate of heating. Mean that if you want to keep full flame or low flame, whatever you would like to desire, how you are playing with the LPG, you could able to play. That's what our target. We are working towards that. So hopefully another in a couple of years, we could have a outcome product in the market. So we also have some first filing on this. So hopefully, and also we got some review report from the examiner as well. Hopefully this get accepted as well. The patent will granted. Coming to the summary, yes, so we have the solar thermal technology for cooking, box type, panel type, constant type. These are very old technologies, and again, there are many incidents also happen. But thing is, we do not know what's the current state of what. But some of the technology we cannot able to prepare all kinds of food. That's one of the major drawback. And constant in solar cooker, yes, we could able to achieve high temperature. Even if you want to make chapati or baking, you could able to do, even you could able to achieve 200 plus degrees centigrade and faster cooking, but it is not economical. I mean that it's relatively expensive per square meter area. I mentioned that around 20,000 per meter square. The use of thermal energy storage mediums stands out for improvement. Mean that yes, exactly, we need thermal energy storage system. Without thermal energy storage system, we cannot able to meet the cooking energy demand. And then also people try to use sensible or latent heat, but thing is latent heat based thermal storage system has very compact, and also you could able to meet the cooking demand, mean that it gives the energy at constant temperature, but it's relatively expensive at this moment. And then maybe it requires more and more R&D effort and as well as commercial installation. But sensible heat storage system, it's less economical, but thing is there are many challenges. It is relatively bulky and then achieving at constant temperature with respect to time. So economic feasibility of solar cooking device is one of the major challenge along with thermal storage. So still we need studies to bring down to develop the technology, to meet all the requirements and also to bring down the economics. An innovative approach is required in solar cooking to increase the usefulness and affordability. And also we need the policies from the government to spread the awareness as well as to provide support for the poor rural families to make this technology to take into the market for either in case of household or even community level cooking. So with this, I'll stop. If there is any queries, I'm happy to address.
Thank you, Dr. Ravi Kumar. Thank you for wonderfully elaborating on the latest advances of solar cooking technology all over the world. And right now, we can take 1 or 2 questions. We have a separate question answer session at the end of the event, but right now we will be taking some questions if there are any.
Sure.
So if there are any,
हम अपना ऑन कर लेंगे.
yeah.
Yeah, please.
No, I think there is one question from Asansol Solar. Yeah,
हेलो.
please carry on.
हाँ बोल रहा था कि हेलो.
Yeah, please.
Please,
हाँ
please.
हाँ बोल रहे थे कि इसके लिए ये सोलर कुकिंग का टेक्नोलॉजी का हम लोगों ने क्या इसके ऊपर हम लोग को कोई सपोर्ट मिल सकता है क्या?
I'm sorry for interrupting you. I'm not good in Hindi, so maybe you have to translate or someone to help me.
Yeah, I'll help you, sir. So what he means is whether this MSMEs can get any support in this kind of research.
हाँ.
I'm sorry.
Whether the MSMEs and the enterprises, small scale enterprises, can get any support from the for this kind of research.
Yes,
This question.
definitely. So we are definitely, because we are R&D institution, we don't have any manufacturing facilities with us. We need support from small scale industries for development. We can come up with a design. Obviously, then we are looking forward support from the small scale or the industries from industry side.
Yes, madam. Dr. Meenakshi Singh has some question.
Just, am I audible?
Yes,
Your
ma'am.
voice.
You're audible.
I would like to know that what is the technology transfer status, whatever you have presented, and actually these technologies are used by, some of the users, by society or something like that.
Yeah, if you
It is a very, very, well planned, comprehensive presentation. I think all over globally, I think you have given the very good, overview of solar cooking system and all. But I just want to know that, where are the gaps right now and how much time it will take, to take this system to the field.
Sure, ma'am. Maybe I'm not sure whether I could able to answer your question completely. The right now we are standing. There are technologies in case if you want to use for the Scheffler disk cutter or concentrating solar thermal technologies. Yes, we could able to utilize to collect the energy even at high temperature, and we could able to utilize. But the issue is right now whatever the installation happening on a thermal route, people have utilized only for making preparing the rice or preparing the dal, not for preparing all kinds of food. Mean that if you want to make frying, yeah, in the laboratory scale people have demonstrated, but thing is when we want to take into the market, somehow it is not materialized. One reason may be the controlling the heating rate. I mean that suppose if I want to have for few minutes initially, if you when you're preparing the curry, when you're putting the oil and the onion other things before frying, you may need relatively high temperature, then later you have to flame down when you're putting the vegetables other things, the controlling part somehow it's missing. So we should have a controlling how we could able to control the heat goes from either solar collector or from energy storage in the cooking pan. So that we need to address. And also we should have user friendly system. Mean that if you someone ask, no, I have a technology which can prepare the meal very nicely, you don't have to pay anything. Yes, fine. But how about preparing other kinds of curry and other things, chapati? At least in the northern part of India, we have little pot of meals as well as roti, the noon time and curry, and then morning and evening, how we can prepare it. Then if you want to have different technology or different source for preparing morning, evening, and noon, so it's not going to success. So we
Yeah.
have a technology, single technology that should address preparing food all 3 times and then any kind of food. Say in LPG, how we could able to make it. Mean that, and even if you have a technology, I need some special utensil for that. No one is going to buy new utensil for this. And though even we raise the LPG price, people stick with that only. So we should have the mean that what I say, if I say in other manner, even these days we all change to the all touchscreen based mobile phone, am I right? So if you even if you have a inexpensive touch normal keypad mobile, no one is you are going to use. So similarly, even if you have a technology inexpensive, unless until if it is not user friendly and if it does not meet all the needs of cooking system, it's difficult to make into the commercialize. We can commercialize, but in the not in the large scale.
Dr. Ravi,
Yes, ma'am.
I'm from CSIR headquarters. I look
Please.
after, the technology transfer related, guidelines also, and I am in technology management directorate. So I just want to ask you one more question, like whatever you have developed in IIT, can those, system can be used for the drying of, what we say, leafy vegetables or something like that?
No, right now we are not developed. We are developing a system. Just we got 1 year over, and we have right now numerical model. We are developing a system now, and maybe it takes another 2 years to at least we'll come to know whether we could able to succeed. Whatever I was talking about, whether we could able to succeed or not. So right now we are
Because the quality what we get, from conventional dryers,
yeah.
that quality is, color sometime it becomes, dull, blackish or something like that. But if we compare the quality with the solar, dryers and all, the quality of the leafy vegetable or something will be, will be retained actually, color. So the
Yes,
quality
ma'am.
will be better. And just I want to ask you, just you can actually identify these gaps, and you can work on at least identify one or two commodities where you can really apply your lab scale, these equipment to the field. That is, I think, very much important.
Exactly, ma'am. So that's what we are looking for. So initially, it is a 3 years project. In the first year, we are developing the cooking device in the lab scale, and then later we'll be taking up and will be installing in the Ladakh, and so the community level cooking.
And
So
your project is funded by whom?
DST,
DST. Okay.
yeah, yeah.
Anyway,
So
sometime
here
we
the
will visit your lab.
maybe once the system is ready, right now it's under we are given for fabrication. So once the system is ready, I'll let you know, ma'am. Through Dr. Chanchal, I'll let you know. So yeah, please, you are feel free to come and visit.
Yes.
So here the idea is, as you mentioned that we would like to have the controls or system which could able to cook any kind of food, and again the control which will be there, whether you flame or low flame, all such things we are planning to have it. But we are not sure how successful we could able to develop. But only time says maybe after a year we'll come to know how much we could able to succeed.
And CSR also can participate, actually, can collaborate with you. Dr.
Please, ma'am.
Sanchit
We are
Kumar
happy
also
to.
is working in this area. He'll be also able to help you, actually, something.
Definitely, madam. We are happy to joining hands with you, ma'am.
Yes, yes. Thank you.
Corporation.
Thank you.
Thank you, Dr. Ravi. Thank you, madam, for your valuable suggestions. So we will be moving forward to the next presentation. The next presentation is by Dr. Chanchal Loha from CSIR CMERI. Dr. Loha is presently working as principal scientist in Energy Research and Technology Group of CSIR CMERI. After completing his MTech from IIT BHU, Dr. Loha received his doctoral degree from Jadavpur University, West Bengal. He has delivered lectured as keynote speaker in number of national and international events. He has executed prestigious project funded under European Union under FP7 scheme. He has been frequent reviewer in prominent journals of energy discipline. His research areas are renewable energy based systems like biomass and solar based systems, clean coal technology, CFD modeling of gas solid multi-phase flow, post harvest processing of agro crops, and so on. He has guided several doctoral and master degree scholars and has supervised various sponsored projects in the fields of solar cooking, biomass pyrolysis, gasification, and related heat and mass transfer applications. He has authored several patents, papers in reviewed, peer-reviewed journals, book chapters, and conference papers. With this short biography, I would request Dr. Chanchal Loha to start his presentation.
Yeah, thank you, Dr. Ishita, and a very good afternoon to all of you. So, my screen is visible?
Yes.
Yes, it is visible.
Okay. So, today I will talk about our development on solar photovoltaic energy-based electric cooking system. Basically, there are two different way of harvesting solar energy. One is solar thermal route, which Professor Robi has covered in a very detail. He has discussed about different solar thermal cooking system, their advantage, disadvantage, and how it can be carried forward. And I will discuss about our development on solar photovoltaic energy based electric cooking system. Now, before going to our work, I'll just briefly discuss about why we need renewable energy, the current situations, what is the importance of the renewable energy, and what is our target, and how solar cooking can play a very important role. So basically, it is evident that India has made a rapid progress in boosting our economy and life standard over last few decades. So basically, from since 2000, India is progressing very significantly, and in spite of COVID-19 pandemic, India could able to sustain its development, and today India is among the fastest growing countries. But this climate change basically is creating a barrier to our development, and day by day it is becoming very significant because it is estimated that in a report, in an international report, that India is already experiencing 1 degree global warming and its effect. And due to this 1 degree global warming, we are experiencing extreme heat wave and severe drought and heavy rainfalls and catastrophic storm, as well as our sea level temperature is increasing and our glaciers are melting. So basically, this is destroying our assets, and it is posing a big barrier to our development. And it is also estimated that India may lose around 3 to 10% of its GDP annually by 2100 due to the climate change. So if the temperature rises from 1 degree to 2 degree, India will lose around 3% of its GDP. And it is increases from 3 degree, then it is more than 10% GDP India will lose. So what will happen? It will basically create increase the our inequality, increase our poverty. So, what is the way to mitigate this effect? So, there is no other way than to develop the renewable energy based technologies. This is the only solution through which we can mitigate our global warming because it is more efficient, it is less polluting, and it can produce immediate benefits such as cleaner air, greater energy security, and rapid job creation. Now, that is why, along with other developing undeveloped countries, India has also set our target in the renewable energy sector. So in COP26, India presented the following five nectar elements, that is Panchatantra of India's climate change. So what are they? The first one is to reach 500 gigawatt of non-fossil energy capacity by 2030. So at present we are having almost 160 gigawatt. So you can understand from 160 gigawatt to 500 gigawatt within next 8 years. So we can expect that how this renewable energy sector will grow within coming days. And then next one is the 50% of its energy requirement from renewable energy by 2030. Third one is the reduction of total projected carbon emission by 1 billion ton. So 1 billion ton CO2 reduction it is targeted by 2030, and the reduction of carbon intensity of the economy by 45% by 2030 over 2005 level. And last but not the least, to achieve the net zero target, that net zero emission by 2070. Though China has targeted it in 2050, but still we are not behind. We have also a list given our target. Now, if we see at the cooking scenario, Indian cooking scenario, basically cooking is a very energy intensive process. And India, about 40% of total household energy is used for cooking in our urban household, whereas it is more than 70% in rural household. And what are the different cooking system used? Basically, there are a different cooking system used in India. First one is the traditional biomass cook stove, which creates a lot of pollution, indoor air pollution, and due to which a lot of death happens everywhere. And still, that a significant portion of our population still use conventional biomass cook stove. Then some people also use ICS, that is improved biomass cook stove, and some portion of people, some other portion of people also use biogas cook stove, but it is day by day it is decreasing because non-availability of the raw material. The biogas based cooking system is reducing. Then also there are some portion they use kerosene stove, and also this kerosene stove is also today we cannot see the more kerosene stove because the price of the kerosene has increased a lot. And mostly used cooking system is India is the LPG. Besides, some people also use the electric cooking system. And during last few years, LPG is promoted as the cleaner cooking alternative in India because LPG is taken as the cleaner compared to solid biomass cooking or coal based cooking or kerosene based cooking, but it is not the cleanest. So basically, to achieve the net zero target, LPG cannot serve the purpose because LPG is a fossil fuel based energy, and burning of 1 kg of LPG produces almost 3 kg of CO2. And another important issue is that about 40% of our LPG demand we are importing. So we are basically losing our foreign exchange. So we are not self-dependent on LPG. Therefore, it is very much important to develop solar energy-based cooking system in India. Now, I am coming to our work on solar photovoltaic energy-based electric cooking system development. So we started working from at the end of 2020. So we received a project from our headquarters for the development of solar energy-based cooking system. So along with this project, we also got some criteria for developing this cooking system. Like this criteria was given like the development of cooking system for domestic application. It should be for domestic application, and the cooking system should be made of indoor application so that the user can cook it by inside the kitchen. They do not need to go outside under the sun, and the utility of the cooking system will be based on will be need based, that is anytime cooking can be done, so that whether it is morning or evening or night or day, anytime cooking should be done. And it should address all the cooking processes like boiling, steaming, frying, so it should be able to cook all type of items, and it should be able to provide sufficient meal for a family of about 4 members. So we started with this criteria, and we develop a solar PV based energy cooking energy system, that is AC based system. So in this system, basically there are solar PV panels where solar energy is converted into electricity, and there is a charge controller which harvests the solar energy optimally, and then there is an inverter which convert the DC electricity to AC, and then whether it any induction cook stove or any resistive cook stove which are available in the market, standard cook stove, that can be used. And when this cook stove is not in use, that excess energy can be stored in the battery so that it can be used in the night also for the cooking. So based on this concept, we have developed one solar cooking system. So this is our first model of solar AC based cooking system. So this cooking system we have developed and we have installed in our guest house. So I can show you some of the clips. So this is the cooking system. So you can see here we are using resistive as well as inductive stove. So we have demonstrated many times this cooking system to our guests, like this or earlier DG Professor Sekhar Simande. So during his visit at CMRI, we have demonstrated it. So this cooking system, basically in our guest house, we have around 100 students are taking meal every day. So this is basically this cooking system they are using for making tea and boiling eggs, etc. So small item they are using it every day. Now, if you see that the cost, now I am coming to the cost. The cost of this system was like 8,000 to 1 lakh. So we realized the cost of this system is high. So we started thinking how to reduce the cost. And then we started thinking like instead of solar AC based system, if we can develop DC based system, then we can reduce the requirement of the inverter. So the cost of the inverter will be reduced. And also there is a loss for converting from DC to AC. So that loss also can be reduced. So in solar DC based cooking system, there will be solar panel, charge controller, battery, and resistive cook stove. But the available resistive cook stove, which are available in the market, they are rated at 220 volt. So if we connect it with the laser voltage, output voltage of 48 volt, it cannot give the required power output. So we realized that we need to develop our own heating coil, and we have developed our own heating coil along with a very properly insulated cook stove, and we developed finally our DC based cook stove. So this is our DC based cook stove. So the panels are placed at the rooftop, and this is the DC based cook stove, and batteries is placed inside this box. So it is some salient features is like that it is simple and compact. So there is no inverter. We could able to eliminate the inverter, so the cost is reduced. And there is a provision for controlling the heat. Here we have given two control. One is 700 watt and another is 1200 watt. But we can also increase the level. And we have also seen that the cooking is very fast and the heating is very uniform. We have measured the temperature of the heating coil using a thermal imaging camera, and we have seen like within 1 minute, this coil can reach around 400 degrees centigrade, which is sufficient for cooking any item, whether it is boiling or frying or steaming. And within 3 minutes, it reaches the steady state condition. That is, the temperature reaches around 665 degrees centigrade. So with this, we can do all type of cooking, and also as I mentioned that we have the battery storage, so we can cook it with this system. We can cook it during day or night, and there is no fuel requirement. And this a properly insulated cook stove basically reduces the heat loss and also contains heat for longer time. It provides the cleanest cooking environment. There is no emission, and it can save 1 ton of CO2 per year. So we have also tested it for cooking different items. Like we have tested it for cooking dal and cooking rice. So you can see that we have tested it for cooking cooking the rice with a pressure cooker. So it we have done it, and it took around 8 minutes, I think. You can see the video. So within after 8 minutes, the first whistle came, and within 8 to 10 minutes, the cooking of rice is completed with pressure cooker. And then we have also done the cooking of the dal without using any pressure cooker. So this is the controlling system. So there are two control, as I told, like first is lower and second is the higher. That is, one is at 700. So this cooking system is rated at 1200 watt. So we can cook it at 700 watt as well as at 1200 watt. So after that, we have tested it for cooking the dal. So dal we have cooked without using pressure cooker, and it is over within 10 minutes. So now I am coming to the cost of this DC-based cooking system. So we have developed two different models of this cooking system. One is steel-based, another is a glass top model. So price of this 48 volt DC-based cooking system will vary from 4,000 to 5,000. And the other system requirement, like to run it, we need solar PV panel, we need battery and charge controller. And depending upon the running time and the backup time, the cost will vary. So basically, based on the capacity, like if someone wants to have a cooking system which can operate up to 2.5 hours and which can give a backup of 1.5 hours, the total cost of this subsystem will be 35,000. So 35 plus 5,000 and 40,000. And if someone wants for higher capacity, like running time for 4 hours and backup time for 5.5 2.5 hours, then the cost will be like 60,000. So 60 plus 5, 65,000. Now we have also calculated the levelized annual cost of cooking. That means we have compared the cost with the LPG. So while calculating the levelized cost of cooking, we have considered its initial cost, its operating maintenance cost, and the life of the system is taken as 25 years, and the nominal interest rate is taken 5%, annual inflation rate is taken as 4%, and the standard data are taken, and the degradation factor for the solar PV panel is taken on 1%, is standard, and for battery it is 2.5%, and the lifetime of battery is 5 years. As you know, 5 years warranty is obtained for the battery, and the lifetime of the charge control is taken as 3 years, and there is no salvage case is taken. So based on these factors, we have calculated the annual levelized cost of cooking. So that means if someone installed solar PV based cooking system, he need to pay 9,067 rupees per year, whereas the same capacity LPG cooking system, he need to pay around 11,000 rupees per annum. So we can see that levelized cost of cooking in case of solar cooking is less compared to the current price of the LPG. Now the technology demonstration, we have, as I told, like we have demonstrated our technology in many occasions. We have demonstrated it to our DG we have demonstrated it to Honorable Union Minister of State, Minister of Education, Dr. Subhash Sarkar. We have also demonstrated during our visit of our RC members along with RC chairman, and also we have demonstrated it during the visit of Dr. Jayanto Kumar Roy, who is a member of Standing Committee on SNT Environment and Forest. We have also implemented one such system in a Braille Academy, that is Asansol Prevention of Blindness Society. So Asan, which is a nearby district of Durgapur. So we have installed it there. There basically 30 students are taking meal every day. So basically main objective was to implement it there is to reduce their LPG load. So they are using it continuously, and they could able to reduce their LPG consumption. And we have also used it in, we have also installed in our guest house as well as in our canteen in our institute. And now I will also discuss some of the other development of some other groups in India. So in 2018, there was a competition done by ONGC. So there, Professor Solanki group from IIT Bombay, they have developed a solar chulha, which is basically solar PV based cooking system. And the solar PV capacity was 1 kilowatt peak, and which provides 3 unit of electricity every day. And they have used induction cook stove, and they have used battery storage for the backup. So they own the first prize. And also they have implemented this cooking system in a village in Bacha in MP. So they have installed total 75 household, and 75 household they have installed their cook stove, and the cost was around 90 lakhs. So basically the cost of each system is coming more than 1 lakh. So this is their system. And then very recently, IOCL, that is Indian Oil Corporation, they have unveiled one solar PV based cooking system, that is Solar Nutan. They have given it the name Solar Nutan. So this is basically, this is also a solar PV based cooking system, and it is for indoor application. And they have also kept the provision for grid connectivity. But here, instead of battery storage, they have used the thermal storage. So what is basically thermal storage? I'll just explain it a little bit. So here, instead of battery, basically there will be one PCM based material. So this is the PCM based material. So the electricity which is generated through this PV panel, that electricity will heat this PCM, and then PCM will provide the heat at a particular constant temperature to the cooking pot. So as the battery can be eliminated with this system, so the cost can be reduced, but there are some challenges. Like in case of PCM, it gives heat at a particular temperature. So suppose when you are cooking milk, and when it is overflowing, you cannot control the temperature. So controlling the temperature is extremely difficult with this type of system. One. Number two, the response of this system is slow, particularly in the morning. It will take a longer time to heat up the PCM. So these are the challenges. So research is going on. I think in the future this will be addressed. Then this can be also a good options. Then if we look at the opportunity, what is the opportunity for solar energy based cooking system? So at present we have almost 30 crores of domestic LPG connection. So if we assume like if we can replace 10% of the LPG users by next 5 years, then basically it will reduce 4.2 million tons of LPG consumption. And it will also reduce the carbon emission by 30 million tons. And it will also give us the opportunity for Make in India. So it will basically, it will cater 30 gigawatt of solar installation. And at present we almost we have around 40 solar panel manufacturer, and we have almost 12 top grade battery manufacturer in India, then 155 small scale startup for manufacturing charge controller, and also there are a lot of startup and small companies who can develop the heating coil. So I think it could be a very good option in terms of the Make in India concept also. So in summary, what we can say like that solar PV energy based electric cooking system is a bright future due to its economic feature. Even though we have seen that LSCC of solar PV cooking system is less than LPG, but the higher initial cost, as per my opinion, higher initial cost might be the barrier for the large scale implementations of this technology, and that is why there are further R&D is required to bring down the initial cost, and CSR CMRA is already working on that. We are now initially we developed for 48 volt DC system. Now we are working on the development of 24 volt system, so that the cost and can be reduced. Initial cost can be reduced. Besides, the widespread awareness towards the benefit of the solar energy-based cooking system is essential to make it more popular. And last but not the least, it will be more attractive if the benefit of the carbon credit is given to the user. So maybe in terms of some subsidy can be given to the user who are using this solar cooking, because they are saving the CO2. So that is basically some policy decision that will also play a very important role for the future of this solar cooking system. So thank you.
Thank you, Dr. Loha. We will be taking questions right now.
Hello, good afternoon.
Yeah,
Yeah,
good
good
afternoon.
afternoon.
Currently, your DC system cost nearly 40,000, right?
Yeah, from 40 to
40,
65.
40,000, right?
Mhm.
Right, right. What is the opportunity to further reduce the cost?
Yeah, our target is basically to reduce it within 30,000.
Okay, within 30,000. Okay, okay. So, is there any possibility to even go down?
Yes, there is possibility. That's why this IOCL, they have developed thermal storage. So instead of battery, so battery is a weakest point here. But
Okay,
there are still challenges. Means whether it is feasible or how much it is acceptable by the user, that we have to see.
right.
Yes, there is the possibility of reducing the cost further.
Yeah, thank you.
Any other question?
Just one question.
Yes,
Yes,
ma'am.
ma'am.
Dr. Loha, very good presentation. Uh,
Thank you, ma'am.
Actually, I would like to know, this is FTT project or FTC project?
This
What
was
you
a,
have
madam,
mentioned.
MLP project.
MLP, which one? The FTT, FTC or FBR NCP?
Uh, that's nothing was mentioned like that. It was just mentioned like it is
Who is handling
MLP,
at headquarter?
and it was given only for 9 months.
Who has coordinated at headquarter?
Yeah, from headquarter, Hariam Jadab sir was coordinating.
Okay, okay, okay. I think it is something different. Okay.
Yeah.
So your project is over?
Yes, madam. It is over.
Okay. So very good. Actually, this, I think now you have to really see that energy saving, how you can really do it. No? That is important.
Exactly, madam.
And what you have asked, you have given in your summary, how you'll achieve that, that you are going to take under some project or how?
Yes, yes. We are planning, and we are also submitting project in other agency also
Okay.
to reduce the initial cost.
Yeah.
So like we are working on Gale. So Dr. TP Jubraj is there. So he will also discuss. So we have some initial discussion. They are interested to take it in collaboration mode.
Okay. That's good. With industry you are working there.
Yes, ma'am.
Okay. Thank you.
Thank you, ma'am.
Thank you.
So we will be moving forward to the next presentation. Our next presentation is by Dr. Debanjan Das of Triple IT NAIA Raipur. Dr. Das is an assistant professor in electronics and communication engineering discipline of Triple IT NAIA Raipur, Chhattisgarh. He has completed his MTech and PhD from the Department of Electrical Engineering, IIT Kharagpur, in the area of sensor and instrumentation. Currently, he is the faculty in charge of IoT and Sensors Lab of Triple IT NAIA Raipur. Along with this, he is holding important responsible posts like PhD faculty coordinator, member of Institute's research consultancy and academic planning committee, etc. Dr. Das has more than 9 years of R&D experience in the sensors and instrumentation, signal processing, etc. He has filed 5 Indian patents with 1 granted. Currently, he is investigating 2 multi-crore funded projects from MEITY and NMICPS Government of India. He has published about more than 60 research papers in international journals and conferences, including prestigious publications in Nature and IEEE. Currently, his main research interests include IoT and smart sensing, signal processing, and predictive maintenance. He is a senior member of important professional bodies like IEEE and IEEE Instrumentation and Measurement Society. So, I request Dr. Das to carry on with his presentation.
Good afternoon, and thank you, Dr. Ishita, for your nice introduction. So let me share screen. Yes, hope my screen is visible.
Yes, it is visible.
Right. So at first, I will like to thank Dr. Loha and Dr. Partho Saritipal to give an opportunity to share some of our work towards this, not exactly the solar cooking system, but as Dr. Loha is correctly said the introductory of my sessions. So as you have seen for solar PV based cooking systems, the battery is an integral part. Okay. So equally from the safety and the operation point of view, it is equally important to know the health of this battery. So currently we are working towards this onboard health prediction of rechargeable battery, and that works majorly that we are doing in context with the IoT. But I hope that same concept we can equally implement or use for these solar based systems, solar based cooking systems, especially, right? So as we have seen that even means we are all of us we are talking about the green energy business, but if you see any consumer based green energy products, so they are automatically it is coming that we need to store it so that I can use that energy at any time. Okay, so on that sense the energy storage like the battery is becoming the integral part, right? Here one of the examples that we can see, right, this battery is part of that. Okay, but these most of the cases these are the rechargeable batteries. Okay, but these rechargeable batteries in under the rechargeable batteries, again for the lifetime and the efficiency point of view, the lithium ion batteries nowadays becoming more and more popular because of this high specific energy, lower cell discharge, niche property, and prolonged battery life. But if we see from the consumer point of view, what we want that my battery should able to store much energy as possible, and along with also it, I want that very fast it should charge it. Uh, but when these two things parallelly we want, so then it comes the problems. Okay, so actually that boost the aging phenomena, and due to that lots of other health problems or the degradation in the battery starts. Okay, so that it comes that the usability and long lifespan, so these are the two competitive things. Okay, now with that point, if the battery, if you are not able to properly maintain it properly, if I don't have the what is the health and the status of my the battery, internal quality of the my battery, so then we may have different kind of other consequences, like all of we know, like this is an example of the electric vehicle, so where due to this battery heating, so suddenly it got fired. Okay, so these are the many times we in newspaper and many other event we have experienced this kind of the battery fire explode, which is sometimes is also dangerous for the user point of view. Okay, so the same things as these the solar based cooking system is also is the usage and the demand, we can say, or the requirement is increasing. So it may happen that similar kind of the incident it may happen, so we have to be ready how to avoid that. Okay, so that is a overall motivation towards my talk, that how I should have the health of my the battery in real time. I should able to do it, I should able to identify when I should when I need to change my battery, so that I can plan the other financial and other requirement subsequently. Right. So with these, if we see the health problems, what are the typical health problems that we face? So these health problems in general we tell that it is a capacity fed problems, and it happens for the different reasons. So one of the there is a certain reasons which are happened external or the aging point of view. Certain the challenges or the problem comes or arises due to this the user how we are using. Like if you see that very material point of view, so this formation of these solid electrolyte passivation layers with the user uses, okay, means with age it happens. So say this is one of the inherent properties. So then it comes the loss of lithium ion inventory, loss of active anode or cathode materials, then the metal dissolution, electrolyte decomposition. So these are the different phenomena it happens. And also another important things, as I mentioned, as users, the overcharge phenomena. Okay, so if my battery management system is not able to do correctly these over protect it from these overcharge phenomena, so then we end up again the problems. Okay, so these are the problems, the defined problems that happen. So we need to identify it. So that is a overall idea. So now when you come the battery health, so we generally use very often these two terms. One is a state of health. Okay, so that we defined what is a ratio of your actual capacity and the your real capacity. Sorry, there is a typo mistake. So this is a QR is a real capacity. Okay, and this state of health it gives a battery ability to store and deliver the electric energy, and so these SOAs or state of health we consider as a short-term battery health prediction parameters. So we are trying to get this SOH. So that is should be our one of the first objectives. Next objectives is that what is a remaining useful life. Okay. Because if when I'm going to change or replace my battery, because suddenly if it's stopped, okay, so getting a new battery and replacing maybe again a hectic task. Okay, so we should have the prior knowledge that what is a lifetime and how much the useful life I have is still with me. Okay, so this is considered as a long-term battery health prediction parameters, and so these are the two important things. Now to address this state of health and the remaining useful life, so there is a different people are working in a different methods are there. So those methods we can broadly classify in two ways. One is a model based and another is a knowledge based. So model based means we do the electrical modeling and mathematical modeling of those battery, and then through model parameters analytically we try to find, okay, if the if this is my degradation happens or this parameter is degrade, so what will be the output voltage, and if my output voltage matches with that, so from there we try to predict, yes, the battery health is degrading due to this reason. But we can understand that model based approach we can't do in the real time. Okay, we can't deploy it on board. Okay, because that is a totally offline process, we can say. So there comes the if the with the advancement of these sensors, IoT, and artificial intelligence, mainly in today's times, that we have, if I have the internal information, if it is even it is not direct parameters, some indirect parameters, indirect health parameters, and from there using with the help of the artificial intelligence like machine learning, deep learning methods, I can have my this state of health and the remaining useful life information, which we can easily implement on board, and we can do the real time. So that is a overall um, the the objectives that we want the onboard prediction of the battery health and communicate that information also using through the IoT. Okay, because in today's times, if we look that even these cooking systems also under a smart home environment that should be linked up with the my IoT systems. So that is the overall idea. So we we took the approach of this knowledge based. So if we see the in general this knowledge based approach, so we are collecting different kind of data. Some of the data may be offline data, some of the data in online data, like you have these the current, voltage, temperatures, charging time, all maybe my real time data, and along with certain other offline experimental data like CC means current to current, current to voltage, charge means all those different other offline data. Then from there, we need to generate, we need to find the certain important features which will have the direct correlations with my this battery state of health. Like now for that, we have to find the good correlation techniques, and then from there, we may require the data dimension reductions, because as we are going to deploy this entire model in on real times on my a cost effective or resource efficient embedded devices. So we can't take all the type of irrelevant data or not highly correlated data. Okay, so that also you have to do. So after that, we know in machine learning techniques, so or machine learning deep learning techniques, there is a especially two way that we should do it. So all entire data we should split up in a certain ratio. So majorly maintain 70:30. So that is a ratio. So 70% data we use for the training purpose. So after training means we used different machine learning models, and then from there we identify which model is most accurate and most sensitive, and that model we use further for testing purpose, and then finally we got our tested models and tested and validated model, and that model we deploy it. Okay, so if you see, so these are the generic implementation framework or the flowchart, starting from your data features generations, then the model training, and finally the model testings. Okay, so now in this point, one things we can understand the features generations, because that is related with my state of my health of my battery is important. Okay, so now for feature generation, again, there is a different techniques. Okay, so people have evolved. So these I have summarized in one slide. So what are the different techniques, different research groups are working. So some of the groups, they are working with the incremental calculation based health features, like the regional capacity, peak value means peak charge value, peak position. Okay, so different characteristics. Some groups, they are working with these time based health features, like the charging time means constant voltage charging time, constant current charging time means a defined mode charging times, or the whole charging time. So based on that, we can generate the features. And some other features, like the different other characteristic features, like the envelope area based health features, like area under the current curve, area under the temperature curves, area under the voltage curves. And then another, the direct parameters that we can use. So that actually comes from the model based approach, like your internal resistance, internal capacitance. Okay, so but this getting access or the real time how the resistance or capacitance value changing, so that real time always a problems. Okay, so for that we require again the offline measurement, and we can do it. Okay, so so these are the different techniques, different research group they are working. Okay, now come to the ML based as I mentioned, so features, and then identify the suitable the model means machine learning based model. So again, for machine learning based model point of view, you have again different kind of algorithm, like your feed forward neural networks algorithms. For that you have the back propagation neural networks, RVFL neural network, extreme learning based. So then in under the recurrent neural networks algorithms, you have a again defined time, like short term memory based, the RNN, because RNN, those are the lightweight. As we are going to implement on the on my resource constant embedded devices, so we should have the model also lightweight. So that is overall notion. Then we have a simple classification or regression kind of algorithms, like your support vector machine, random forest, or simple the probabilistic algorithm like Gaussian progression. Okay, so the Gaussian process regression is a very under this the health predictions point of view. Okay, but Still, we can because but that Gaussian process regression sometimes it is also requires more computation complexity. So that's why people are looking for to prune the developed the model so that we can deploy it with using the minimum the power and the minimum the computation complexity. So with this, what we are working, so these I have taken as a specific examples. So I'll just show now subsequent slide that what we are working under this. So as I mentioned, the onboard health predictions of my these the rechargeable batteries. So and these works we are doing in the vision of the IoT, because we know the IoT systems runs with the battery, because IoT, the systems means that we call the sensor node we placed at the remote locations. So where those systems is also connected with the energy harvesters, different kind of energy harvesters. So, but in open environment, the solar is very popular. So we have the solar panels, and then my sensor node, and in sensor node I have my my rechargeable batteries. Okay, so the objective is to how I should identify the health of my that rechargeable battery present in my that sensor node. So that is a work that we are working, and so that we developed a next generation's internet of thing means that node, and that we name as a iThing. Okay, so which is having this the battery health self monitoring functionalities. Okay, so in the next slide, yes, here you can see the architectures of that our iThing. So here we have that external sensor that as it is, so we are not touching this part. So what we integrated, so along with these rechargeable batteries, we have incorporated these three components mainly. So we have incorporated a current sensor, means onboard current sensor, which will measure the this current means charging current of this your rechargeable battery. And then there is a these two module is also implemented, like maximum charge point tracking system and the RUL prediction unit. Okay, so this is implemented on board controllers, and I'll show that in subsequently what we did under that, and how we also did it, and what is our performance. And the idea is that if it will always show that what is a it will update the users what is a state of health, and also the what is a remaining useful life you have, means when before you replace that particular battery. Okay, or replacement maybe the your end of life replacement maybe in between you have some other the damages happens. Okay, so which requires immediate attentions. Okay, so that is the overall idea. So this a modified the sensor node that we have developed, and as I mentioned that we name as a iThing. Now come to that point that how we are predicting the health. Okay, so of my battery. So this is a process steps. So at first the rechargeable battery, so that we are taking the data, and then from this we are extracting the certain health indicators. Okay, as I mentioned, so in real time we want to do, so we are taking some indirect health indicators from our measured data, and then that health indicators we are at first giving to a ELM based neural networks. Okay, so which will calculate the SOH, means state of health, and then this SOH, and along with those health indicators, we are giving to another networks to find the remaining useful life. So we are doing two things step by step. At first, identify the SOH, means state of health, and next is from those measured SOH and means the measured data, means health indicator data, we are going to calculate what is my remaining useful life. So now come to the health indicator extraction. So here, as I mentioned, different people have used different kind of health indicators or the features. So here we have taken that the the time interval of equal charging voltage difference. So that we name is TIECVD. So that is the health indicators. Okay, because as practically also you can you know, right, if you want to maintain the same voltage difference. Okay, so as my battery age is reduces, so to maintain the same charging time, same voltage, my time requirement will be less because of the battery degradations. Okay, so we have calculated that, and for that here we have taken the is that we represent as a percentile range to make it normalized. Okay, so here we have taken the value. So this we did experiment, and from there we have identified this range is giving the better results. So from there we have identified this TIECVD health indicator decreases with the increasing in cycle numbers, means with the uses. So now next, as I mentioned, so let's see that we have to also test whether these extracted features is having the correlation with my SOH and RUL or not, because if it is not, so then it is not useful. Okay, so we did this Pearson correlation, and this is the correlation graphs. From there you can understand that your this CVD means TV1, TV1 to 2, TV1 to 3, and TV2 to 3. So the SOH and RUL, you can see that highly correlated. Okay, so from there we confirm yes, they have a good correlation. So we further proceed using that. So next, for SOH predictions, so we used ELM, so which is extreme learning machines. Because it is fast learning, it has a fast learning speed and also good generalization capability and less computational burdens. Okay, because as our primary objective is that we want to deploy that model on my onboard the embedded device or computing devices. Okay, and then this actually this if you see the ELA models, it has input node and some hidden nodes. Okay, and this weight between the hidden and output layers are learned analytically. And on thing you can see here, there is no back propagation things. Okay, so computationally it is less burden. Okay, so but also parallelly we can it can give the good accuracy. Okay, so in our case we have used 100 hidden nodes and ReLU activation function with a cost function of 1, and then we have given this health indicator, the already calculated 3 health indicators in our networks, and we predict the SOH. Okay, so now here in this um, table, you can see that what the performance of our model. Now here we have taken 3 different batteries, which is the data is collected under different means charging policy and different batch. So to prove that yes, the how generalized our model for all the different charging policy and different kind of batteries. So from this, we identified that it has high accuracy respective of charging policy and even the lifetimes, and low runtime, and it's a real-time health. The runtime also you can see it takes a few milliseconds. Means so that means we can say that yes, it is near real time. We can predict the what is my state of health. And we also parallelly compared the performance of ELM with the other deep learning models. And from there, we have also seen that ELM outperform among all. So after, so even we further validated that we changed the means testing starting point, because we may interested to see my health of my battery at any times. So to prove that yes, it works throughout the my battery life cycles. Okay, so we perform that experiment. Okay, so that you can see that starting time combination have changed like 60%, 70%, 80%, again for the different battery batch size. And see all these cases we can see from this RMAC and the mean square error that effective SOS prediction during the entire lifetimes it is more effective and in a better accuracy if the prediction start at the later point. Okay, so in all those things is proves that the model is workable for in real time SOH prediction of the battery. Next, after getting the SOH, our next objective is to find the what is the remaining useful life. So for that, we use the random vector functionally. So which is again the fast learning speed and less computational times with the same reason because we want to deploy it. So in this case, we have again used 100 hidden nodes and the ReLU activation functions, and this shows the again the performance of these our proposed or developed models. Like again the same battery different battery IDs. Okay, so you can see that the RMAC and the MA score is very low. Okay, and this shows your actual and the predicted RUL. Okay, from this we can say that this RVFL gives the good predictions of the RUL, and this table it shows the comparison of different algorithms, and from there we establish RVFL is the best one for this kind of systems. So then parallelly also another important things we also need to know that what is a knee point. Okay, so knee point is nothing but the point after which the value of SOH degrades rapidly. Okay, because so then I don't have that much controls. Okay, so means if knee point arrives means I need to have some indication there, right? I should plan to change my battery. Okay, so this gives an early warning. Okay, so we need to calculate very often this knee point. Okay, so our model also able to predict this knee point. Okay, so so that also we prove it. So then next we also validated yes it can be deployed in the real times and in a resource constant environment. And to prove that we have taken a Raspberry Pi 3B, which is a low resource constant devices that we very often use in IoT kind of devices. And we have taken this lithium ion battery, and we have performed, and it can identify the, we have taken a new lithium ion battery, so it identify the SOH and RUL in a quite accurately. And also to prove that yes it can be done on the edge, because if I'm doing on my on board, so power consumption is one of the important things. So keeping in the consideration that the inherent power consumption of the Raspberry Pi, the embedded devices. Okay, so we have seen that when this our model start computing, so there is nearly means 0.17 to around nearly 0.112 means 2.2 if we consider, so nearly 0.5 what the power requirement. Okay, so that we have compared, yes, so that is means comparatively less power that it's taking when it is doing the this calculation of this SOH and RUL. Okay, so and that is also that we have programmed it that we did this as a schedule based, like it will not do each and every minutes, means because we know this battery to charge to discharge what is the time it takes. So after that, so maybe we tested that each every day it will do only once. So with that point we have found that it reduces the overall energy consumptions. So now come to the so this is the thing that we have developed, but in the process we have also identified what are the challenges if we really want to do it. So first challenge is the data quality. Okay, because that as the prediction is happening based on the data, right? So the reliability and the validity of the data is very much important. Next, while in the development, we have also identified the issues related to the machine learning. That because the machine learning, many machine learning model is required the high computational resources, and also another thing, the class imbalance issue. Class imbalance issue means the how many healthy data you have compared to the normal data. Okay, because the getting healthy data is sometimes is very difficult. Okay, so that is again the class imbalance issue. So to handle that is again a next challenge. And the last is the integration of this train model on the resource constant devices. Resource and energy constant devices is again another challenge. Okay, so overall, yes, we did certain extents, but we are further working to how to reduce these power consumptions and also the runtime, the turnaround time, all those things, so that we can do much more faster way the health predictions and much more efficient way. So with this, I'll summarize that we have seen the battery health prediction is crucial for any consumer-based solar cookers. So here I have taken in a generalized way, but I hope the same concept or the similar kind of things we can also, or it is required for these PV-based solar cookers. And there's for do the real time we can use this data driven approach. Okay, and automated health indicator extractions is important, and for that we can use certain techniques that we have developed. And finally, the optimized random learning algorithms can accurately predict the battery SOS and prediction. So, and which also we can see which we can deploy in a low cost embedded devices. So with this, I'll end up my talk. If there is any questions and queries, I'll happy to address it. Thank you.
Thank you, Dr. Das. Now we'll be taking the questions.
Ask if any other not question, can I ask question?
Sure, ma'am. Sure.
This your health monitoring, can you also actually help in creating some standards?
Okay.
How you can correlate your research with the standards of the device?
Yes, madam. So that's why we have the data that we have taken. So that is a standard data set. So standard open source data set. So with that, we develop these things. This first thing. Second things, we are also testing, means after deploying the model. So we are testing and validating those things experimentally in our lab conditions.
So are you involving in the standards of the regulatory authorities in your case? Are you also using those standards?
Okay, you're telling that. Yes, madam.
So which is
Means
the authority controls the standard of these? National
like
authority,
see,
national
means ma'am,
authority.
like for electric vehicle point of view, mainly this work is most of the people or the regulation or the standard came from the electric vehicle point of view.
So which is the
Because
national authority? Can you name the national authority which controls the standards of this whatever device you are going to?
this that I have to look into, madam. So that part, yes, I didn't do it. So maybe that we'll look into.
Because see, any product you want to come into the market or anything, whatever you are doing, finally it has to apply for the field. So it has to meet the standards whichever used by our country or maybe outside of the country. So always you should really keep in mind standards, whether you are able to following those for developing your device. Thank you.
Thank you, Dr. Das. Thank you, madam.
One more question, if I may.
Yes.
This is from Yuvraj Gale.
Yes, sir. Please.
Yeah, Mr. Das, Dr. Das, is this the scheme is flexible in the sense that whether my battery configuration changes, like if it is a nickel cadmium or a lead acid battery, is your ML programming needs to be entirely reprogrammed and trained in a different manner as compared to a lithium polymer or a lithium ion battery?
Yes, so that's the point that I mentioned. The how we are extracting the features. Okay, so far we did with the lithium. So and also as it is a knowledge base, so if we don't have the other data, so then you can't. Okay, so we should in our data set, initial the data, input data, we should have that kind of battery also. Yes, but that we didn't do it. But if we can embed those means other than the lithium and battery data also in our model training point of view, so then we can do it.
Okay, thank you.
Thank you. Thank you, Dr. Das. So we will be moving to the next presentation now. So now it's turn to hear from our industry experts present in the panel. So our next speaker is Mr. Vimal Kumar, co-founder Finovista New Delhi. Mr. Kumar is the in-country program lead, Modern Energy Cooking Services Program in India, and the co-founder of Finovista. He is CA IIB MBA in Finance and Mathematics honors graduate. Mr. Kumar holds strong expertise in program and fund management, multi-state program management, in-country representation, sustainable finance, technology transfer management, international trade and investment, strategy and corporate development for startups, spin-off, and MSMEs. His firm Finovista works in-country representation, project management consulting, capacity building, and technology management with developmental agencies, government bodies, research agencies, and businesses across the globe in areas of environment, social and governance, energy, clean cooking, innovative solutions, sustainable finance, healthcare, Industry 4.0, and social enterprise development. He is a member and expert of various government committees and an avid speaker at national and international conferences. With this biography, I would invite Mr. Kumar to start his presentation. Over to you, sir.
Yeah, thank you, Dr. Ikshita, for warm welcome. So, allow my screen on the sharing mode.
Yes, you can share your slides.
Yeah, hope my screen is visible.
Yeah, it is visible.
Yeah. So, good afternoon, all. Just a minute. Yeah. Uh, Sorry. Yeah, good afternoon, all, and thank you for inviting me. Special thanks to CMRA and Dr. Loha for inviting me. I'm going to talk about that overall opportunity in the clean cooking and then how the modern energy can actually play the role and what is the role of solar cooking. So basically, I'm a part of the program, which is we call it a Modern Energy Cooking Services Program. It's a very large program. We are trying to transition from biomass to clean cooking in Southeast Asia and Africa. And India, we always see as an important country, considering that India has the very good opportunity to talk about this area, as we are a consumer, we are a technology leaders in this space. And why it is important, though the previous speakers has talked about from the technology perspective, now I am going to talk about the techno-economic perspective. So over 70 million population in India is still relying on the biomass and firewood, and the cost of and why they are still relying on the biomass and firewood, in spite of we are having the solution from the LPG, solar thermal PV based electrical cooking and all, because the cost is going very high. Some of the speakers has already touched upon that why it is important and why people will going to pick. So we have actually identified some of the area which I'm going to discuss, that what you need to think when you are going from the technology developer perspective, the technology user perspective. If I talk about the global access of clean cooking, 4 billion people, about 400 crores people don't have access to clean cooking, and this is not only impacting the health, but it is also impacting the economy. So 2.4 trillion dollar is the economic opportunity is impacted through the cooking, dirty cooking. and the adverse impact on the health is costing about globally 1.4 trillion, climate 0.2 trillion, and the loss of productivity is about 0.8 trillion. This is the World Bank report on the state of energy to the modern cooking services, and this was the mix and World Bank study together. In India, it is not like that we have not did. We have already did our work while promoting the Pradhan Mantri Ujjwala Yojana, which is the super successful program. And recently, the Niti Aayog, along with the CEE and GIZ, they have come out with a clean cooking roadmap. And the mostly that why we need to pace up at this stage. So as we know, the government of India is facing, or the India is actually facing tremendous challenges, right from the energy insecurity angle, right from the cost is going up, the health crisis, and in the recent war actually highlighted that the need of Atmanirbhar Bharat is very, very important, where we can actually generate our own energy, consume our own energy. Electricity and solar can be the one of the area where actually we can work together. Traditionally, this is the 2011 census data, which says that about 67% people are still relying on the biomass. The data may be refined when the new census will come. And if we talk about the death also, about 5 lakhs people are dying every year, since this is the not come to the framework and all. That's why nobody talks about that, but this is costing us in health also and in life also. And poor air quality, actually this sector contributes about 4% of India greenhouse gas emission. So in every manner we should actually move from the biomass to the newer fuel. And when we talked about India, under the Pradhan Mantri Ujjwala Yojana, phase 1, phase 2, they have provided 90 million connections, which is 9 crore connection to the household. And needless to mention that we import most of our cooking fuel, and when we import most of the cooking fuel, currently it is also highlighted that a country like India is actually facing the challenge of the foreign reserve. So this is going to be have the multiple impact. Additionally, in the LPG fuel, government have to provide the subsidy. Most of the previous speaker talked about that, how to actually reduce the cost, or how to bring the carbon finance on. I'm going to talk about in totality on that. Shifting to the modern energy based cooking, which is a solar and electric, is important, considering that India has the sufficient coverage of electricity, and wherever electricity is not available, we have a sufficient coverage should be provided by the solar. And the solar can be the affordable, like the previous speakers mentioned about that the challenges. So I am going to talk about that, how to convert the challenges into the opportunity. This is the one of the data which World Bank has actually published. If you see, this black rose is talking about the fire and charcoal, and the green and the reddish part is talking about the AC and DC with the battery. So if you see that AC and DC battery is cost is going to regularly down. So by 20, we have taken the data from the 20 to 25. So cost is actually going down, but the charcoal and firewood going up. We may have the justification that charcoal prices or the firewood prices are cheaper, but it may not cheaper or may not accessible in some of the areas, especially the urban areas. Even in the poor areas or rural areas, the cost of collection is very, very high. So what is the solution? So IEA has actually suggested that why not to have an integrated solution which involve your electricity and solar together. So entire household is getting the energy. As we know that whenever we are doing the cooking, when we are actually working for the cooking in the morning and evening, the sunlight intensity is not there. And whenever the sunlight intensity is there, we are not cooking at that point of time. So what is the solution? These are the challenges which we have. So now, as I mentioned, this is the UK government funded program, and my company Finovista is in-country partner for next program in India, and we are actually enabling the clean cooking in India. I'll talk about that, what are the impact which we have created. While doing this program, we interact with all types of agency. We mentioned about that, Dr. Meenakshi highlighted that when you have the technology, you have to go in a market. So when you're going in a market, how many stakeholders can come in a picture? So we have identified all types of stakeholder which can actually responsible or which can be the fulcrum of promoting the clean cooking. So when something is happening, so we require innovation, we require pilot and demonstration, we require policy support, we require skill up support, we require mapping who are the partners, outreach and promotion, knowledge sharing, visit delegations. Manufacturing is the key role have to play, because the technology whatever we are developing, the ultimately the responsibility lies to the taking to the user is manufacturers, and the partners can actually help them in enabling. So we are actually doing the outreach and promotion, so the more and more acceptability will be there. We are doing the innovation management. I will be talking in length in this area, that recently we have did some program. We are providing the scale up and market access support. We are working with the device manufacturer, startups, Bureau of Energy Efficiency, BIS, MNRE, PSA office, ESL to provide the access. Technology demonstration and pilot, we are working with the Kolkata based CESC. We are trying to understand that how electric cooking can be possible. So I'm sorry that I will be talking both as a combination, and why a combination is important. As we know, the yesterday, day before yesterday, we have India has passed the Energy Conservation Act 2022, in which we are already claiming that 50% of the energy should come from the fossil, non-fossil fuel. So we earn 500 gigawatts of energy, which means that our existing electricity generation is going to stay, and the new generation has to be added. And Dr. Loha highlighted that the space need to be accelerated in the solar side, and the coal is also going to be there. So we need to have the right balance, and and in such scenario, decentralized renewable energy is going to play a vital role. A small system which can be lightening your houses, lightening your kitchen salon is going to play the role. And other agencies, we are also trying to bring them in a common platform, how to support this sector. What impact we have created? So we as a mix program, when we thought about how to do what to do with the promotion of the program, so we have identified various domain where we can actually provide the impact. One of the initiative we have taken as the we are organizing talk series on a monthly basis. It is an interactive platform where the entire ecosystem, not from India only, but entire globe, they come, talk, discuss, share their ideas, what is happening, and we do in a different topics. So like some of the area was in women in clean cooking, some of the area was that launch of India e-cookbook, etc. And we are positioning India as we are assisting India to position as a global manufacturing hub. Thanks to the China debacle, India has the very good opportunity, and you as a researcher from the research agency has to play the very vital role. Everybody highlighted that there is the need of technology, and there is a lot of scope for the technology development, and thanks to the technology like solar and electricity and any future fuel have the lot of scope. So possibly in a biomass and LPG and PNG, we can only increase the efficiency in the LPG and PNG, which IIP Dehradun has did the same project, BPCL has did for the LPG and all. So there is a scope, wider scope lies in the solar and electricity. And why it is not done? Because nobody is focused too much on that. I will be discussing that, our experiences into that. Then another important aspect is that this entire sector need enhanced collaborations. So I work very closely with the CSIR also in this subject. Dr. Loha is in our panel also, and I regularly interact with Dr. Meenakshi and all. So, and your CSIR colleague who is working in a clean cooking. So they can actually help us in technology, bringing out the technology and all. policy is the one of the most important. Without government backing, this kind of things is not taking a scale or mass movement. And I'm happy to share that Go Electric campaign by the government of India has launched and only talking about electric vehicle and electric cooking. They're not talking about a heating and cooling or anything else. So imagine the intensity which we need to provide and is provided. Now we have to pick up. We as a program, we are actually giving a lot of input during the budgets and all. So the sector can pick up, etc. And another important aspect, your DG, the new DG, she is part of the energy storage, and she is part of the national mission for the electric mobility. So potentially she can be one of the person we can actually approach her, involve her, that how she can actually help the CSIR and the entire ecosystem to take to the next level and all. And then while doing this, user is the most important aspects of entire activity. As we know, the solar cooker is very costly if you add everything, and we need a commercial model where the user is paying the commercial value and the companies are providing the optimum value. So user and manufacturer can come to the level where the user is buying happily and manufacturer able to sell the devices happily. So for that, we are actually we are working with the Energy Efficiency Services Limited, which is EESL, for 20,000 deployment of electric pressure cooker in Delhi. This project is already approved. We are going on the due diligence phase and all. This is the one of the initiative we are going to establish that cooking is possible and mass scale cooking is possible. I will be also going to talk about that people have lot of apprehension in the solar cooking and the electric cooking, taste, health, nutrition sector, etc., which I am going to also address that. The stakeholder I already mentioned in my previous slide is most important, but we are working with a stakeholder. We are integrating the entire stakeholder who can be the responsible for that. We have did another interesting aspect. We have developed the India e-cookbook, which is electric cookbook, under which we have established that cost of cooking in electricity is much cheaper than the cost of LPG. And some of the speakers highlighted that why cooking will be going to pick up. So we have identified 6 areas, and the 6 areas very important for the any solution. So it has to be easily available to the user. It has to be emission free or less emission. Has to be affordable, and it is going to be the safe device also. Safety is another important aspect where we should be looking into that. Convenience, we should never leave this. Convenience is nowadays is going to be most important. Like people are sometimes walking, not walking, they can spend their quality time in some other activities, maybe economic activities or not. So convenience should be most important aspects into that. To promote this, the e-cookbook is helping us in establishing our fact. This report is available on our portal. You can go download. This is available in the e-version. And to support entrepreneurs and to support the technology developer, first time in India we ran the entrepreneurship development program in clean cooking in partnership with the principal scientific advisor office to the government of India and EESL, Energy Efficiency Services Limited, under which we have taken this program in the 2 level. In the level 1, we have shortlisted 13 applicants. We have trained them for 45 calendar days, and then we selected for the phase 2. Under the phase 2, we have selected 3 startups. We have provided grant amount of 2.5 lakhs each and 45 days of mentoring, one-to-one mentoring. So we are supporting that, and this is the not end here. Some of the people have asked how we can get a funding. So I'm happy to share that we have already got approval of launching the investor pitching session, where we are going to bring the startup or innovator with the private capital VC fund, so they can actually pitch their ideas and the VC can pick those opportunity. Another important thing which we are going to do in partnership with the Electropreneur Park Delhi University, which is an incubation center promoted by the MIT, we are going to run the innovation challenge in clean cooking. This is also going to be the first time in India in such intensity, where we are developing the solution for the India, and they have an intention to go global. Please feel free with your technology, apply for that. Also, it is going to come may very soon. Investor pitching is already scheduled for November or so, and for the investor challenge, it may take some time. Talk series I already talked. So this is the very important aspects. Some of the people from in this group are also speaker, and since it's interactive, we take a various topic, and we'll happy to talk any subject and all. If you want to talk about in particular aspects, e-cookbook, I already spoken about that. We have established that when you're doing a cooking in electric pressure cooker, electric pressure cooker can be through the solar, can be through the electric. If you put the AC DC converter, and AC DC converter, why we are saying that the sunlight is available when cooking is not happening. So we need storage, we need to provide convenience to the user, and need to provide the affordable solution. So Max program is committed for supporting people like you who are developing in this. We have the technology, we have the financial resources, we have the other resources which we can happily share that our findings, our ideas, even our funding also through the competitive routes. So those things are also available. We also did try to understand that what kind of cooking is done in India and in other country, where we are talking about taking Indian company to the global scale. So we did a lot of mapping that what kind of food Indian eat and what kind of food different parts of the world eat, and is there any similarity. So which means that the energy, the devices used in India can be relevant in the other countries also. So Indian company who is developing a technology, or let's say the Simeri has developed this technology can go to anywhere in the world, and we are working with the IIT Dehradun to taking their technology to the African market for the IIP, this efficient PNG burner one. This program I talked about, these are the three gentlemen who got the top three. The Yatin, he is the founder of Nosh. He's the AI based automated cooking through the electricity. The Devang Joshi, he is the founder of Rudra Solar. He has developed a technology which can actually, it can run on the solar direct, and it has the storage also. So you don't have to wait for the sunlight to be available. And then we have also funded to the Dr. Ajay Chandak. He is also developing that it has the thermal battery. And you already mentioned that for doing a cooking in India, we require certain temperature, and certain temperature can be produced through the DC devices and the AC devices. So DC has the more wider scope, subject that DC can be up to 300 watts, and 48 volts is the very much doable, which the CMERI has this technology. So this technology need to be proven and all and taken to the market, and we are able to help them also to take. And some of the opportunity for the solar cooking lies like Ladakh is going to be first carbon neutral district in India. They are looking for the solar solution, which can actually how we can cook through the solar for 65,000 household we have there. Solar with the battery is the very good solution, considering that it can provide 24-hour energy supply in your kitchen. Solar plus battery plus electricity is the one of the best combination. Of course, cost is going very high, but government is very sensitive. They have launched the PLI scheme on the ACC also, which actually going to help in reducing the cost of battery and the solar also. So lot of activities are going on, and we are hoping that it will come down, the cost will come down, so uses can be there. And other alternate fuel can be also very important, like the hydrogen, methane. The government of now in the Energy Conservation Act, they talked about that green hydrogen, green ammonia, and etc. This is the some of the activities which we have actually did with we have partnered with the CII, that is Confederation of Indian Industry, and we brought the stakeholder together. We talked about that how we can actually sensitize the sector. We got the good presence from the government of India at the Niti Aayog level, the Ministry of New and Renewable Energy level, and all. Uh, UFLA, this is a very successful, good story of the UFLA also. UFLA is the Indian startup based out of Pune, working in electric cooking, especially the electric pressure cooker, that is this device. This company owned the Global Leap Award. This Global Leap Award is the international award, global award. They identify the best energy efficient devices across the globe. The UFLA is the one out of two company got the award. They got the feature in the book which we developed. They got the certificate, and they most importantly they got the cash award of $50,000. So which actually helped them in earlier they were used to procure from China, assemble in India, and now they have their own manufacturing plant in India, in Pune. They are talking about 50% of Indianization, including in this device you have a 4 feature: heating system, you have a insulation, you have a pressurization, and we have an automatic controller. So all these are the core hardcore of this technology. So they are talking about they can actually make 50% of this device. And why they are talking? Because the EESL procurement norm suggests, the government of India norm suggests, your devices has to be Indianized. So that's why it is important. We are working with the discoms, so they can actually talk about that. Running the, we have also partnered at some point of time with the BIRAC, but our funding conditions not allowed, we have not moved forward. But definitely we are launching with our own this time. Solar cooking scenario, as we know that I don't want to talk in this because the previous speakers has already covered. But important aspect is, yes, there is a scope, there is the opportunity, and the India should actually look forward for that. These are the typical devices. Here the last part I want to cover, this is the Chinese company E1, who has developed the technology. This technology is just 24 volt, 300 watt. So such kind of solutions we are looking as a next program also. We know that there is the challenges, and our support is available for the people who are looking for some solutions and they have some innovative ideas. Please come approach to us. We are available for you. We can help you as much as we can. This case study already covered by the previous speaker. So third point is very important. The Ladakh region is going to be very hotspot of the Indian solar cooking, and ESL has also expressed the view that can we have the household level solar cooking solution. Maybe the CIMERI can play the vital role, that they can do the pilot of 5 devices in the Ladakh. I can facilitate the discussions into that, and let us see how the acceptability by the people and all. And ESL, once they agree, they can go to the any level to deploy, and possibly entire 65,000 households can be deployed. They are our gems. So they are the people in our EDP, Entrepreneurship Development Program, and working in a solar devices. So Praveen Kumar is another founder from the Sanprit. He has the technology which is actually working on the ETC tube. The Mr. Nagarajan is talking about that integrated device like CIMERI is talking the same. I'm not technical person, so don't want to go into that. The Devang Joshi, who won the award also, he is talking about phase change material based on the thermal heating system and all. The Vishakha is the pure market person, so we can actually talk to her also, that taking your product to market, she provide the market support for the technology. Ajay Chandak has developed his own technology, the PV panel, which can be installed outside in your balcony, rooftop and all, and it can actually light your kitchen. One announcement, like we mentioned that we are here to promote the clean cooking sector. We are a part of the long-term program. The first time in India, we are organizing the Modern Energy Cooking Forum. This is the global initiative started by India in India, and this is in-person event. So please come join us. the very limited seat, please apply for that, and then we will be inviting you based on some criteria and all. But that is happening in India Habitat Center in Delhi on 23rd of September. With this, I like to end my presentation. I will happy for the Q&A, and these are our coordinates. So please feel free to reach out to any of us. We will assist you. Thank you. And thank you, Simeri, for giving me such a nice opportunity interacting with the very learned people.
Thank you, Dr. Kumar, for this very informative presentation. I'm sure there might be very many questions. So we'll be welcoming the questions right now.
Yeah. Dr. Sarkar, can I have your question?
Sure, sure.
Yeah. Mr. Vimal, thank you for the interesting presentation. This is Ravikma from ID Delhi. Are you able to hear me?
Yeah. Please go ahead. Yeah, Dr. Ravi, please go ahead.
Yeah. So I have one generic question. You talked about electric cooking. So just I would like to hear your views. So there are multiple ways we can cook. As I covered solar thermal cooking, and then Mr. Dr. Loka covered about solar PV based cooking, induction cooking, or the restive type cooking. And you also talked about the solar PV based cooking. So, and also during Dr. Loka presentation, he mentioned that solar PV based cooking with thermal battery, thermal energy storage, right? Not the electrical battery, thermal energy storage. So, do you feel that solar thermal based technologies with thermal energy storage and cooking? This is one option. The secondary option is solar PV and then electrical battery and then either induction or restive cooking. The third option is solar PV and thermal energy storage and cooking. So, which one do you feel it can take further? It can reach in the commercial market. And could you please share your views on the same?
See, thermal, that you have to add electronics into mechanically. So that will be the best solution. Electronics, I don't know, I'm right answering in the right technical word, but definitely that you have to add electronic component to that. You have to efficiency can only come when you have the automatic controller. Automatic controller is needed. So from my point of view, you should have the electricity is already available. Maybe that we can debate that quality of electricity, but I mentioned about that government is actually very active, and they have also placed a bill, and before that they have launched the citizen charter for 24/7 power. So this is going to happen very soon, that 24 hours electricity is going to be available, as we already have the resources. Installed capacity is very big. So electricity in our house coupled with the solar panel with the battery is the one of the best combination to provide the efficiency is also very important. So cost should be controlled in terms of capex plus opex. Possibly this solution can provide, and for that PLI scheme for the solar and ACC can help for that.
Yeah, sure. Maybe in addition to the same, the response, thank you for the clarity. And so maybe since you are talking about 24 hours electricity for all the application, hopefully time-based tariff also may come into the picture. That's what we are looking for, because there are a lot of resistance. But actually time-based tariff also really important. In case if time-based tariff is implemented for the electricity, then obviously the cooking in the morning and late in the hours, except during the peak time, am I right? So the cost of electricity also will go up. So do you feel that, as I discussed one of the option, let us have the either electricity from the solar PV or from the grid, and then convert into heat. Anyway, at the end of the day, we are going to use the energy, cooking energy, the energy for the cooking, in the form of heat. So let me store it in the form of heat, and then let me utilize whenever I need for cooking, utilize. So what is your view in this regard? I mean, that do you feel that it will become cost competitive? Assume that whatever the talked about challenges, I am going to address all the challenges. In such scenario, do you feel that among all the three options I mentioned, which option play major role, and which one could able to take into the market?
So I like to give a real life example what we are actually doing, and I really appreciate Dr. Das to have the presentation, and he is talking about AI. BMS is going to be very important before discussing entire thing. See, currently the government of India is facing multiple challenges in terms of energy. Energy access is the government responsibility in city, in state, in district, in country. So government across the world, they have invested lot of money for the energy access. Now the energy is already provided. Now better utilization of energy is the next question which is coming. The NTPC people used to say me earlier that you put a plant anywhere, the demand will come. Now they have to do the modeling for that. So they're not just putting the plant anywhere, but they are doing the cost benefit analysis and then they're putting the plant. So this in scenario is completely changed. Coming to your question, uh, we are also working with the EESL and the IIT itself. Means Dr. Panigrahi and all. I have spoken twice, thrice to him also. Like we have the 403 gigawatts of installed capacity of electricity. My peak demand is 210. We all know that what does peak demand means. One spur of the moment that demand will come. For that, you have provided through 200 gigawatts of electricity installed capacity, which is not used. How actually we can flatten the demand, and the flattening of demand can come through the point which you are mentioning. Like let's say have every household have the electric battery, and maybe the electric vehicle is another important component, because during the charging time it can be clubbed with the grid and the in a parking lot, and the Professor Das can develop some technology so it can be the bi-directional. And we have given in input to the in a budget also, in the CE also, that Central Electricity Act also, like why not having the differential peak off peak power tariff also for India. We have not we are already discussing with the government, though it is not come yet, but definitely we are keep pushing to the government at the policy level and all. And once this will be done, I as a household, I can be using the taking the energy from the grid or the low price. During the peak hour, I will be become a supplier. I can earning some money from that also. And imagine this can be possible nowadays as the chemical is actually improved. So lithium is talking about 5,000 cycles and all. We have a 365 days in a year. If I am recharging my battery twice, two times in sorry, means every in 2 days or so, even I can actually able to save. So life of the battery is another very important. The cost of the battery is very important. If it is possible, this is a very good solution, and actually government should do that. And we are happy to take this cause further and provide the supports.
Thank you, Mr. Vimal, for all this clarification. Whenever, since you have already collaboration with Professor Ponegre, whenever you visit my office, just above to his office, whenever
Okay.
visiting ID, let me know so we can have a short discussion. Thank you for the
Sure.
interesting presentation.
Yeah, and Professor Vijay is also working in your side in the rural technology. Maybe that you can take.
Yeah,
Dr. Meenakshi was talking about transfer of technology. Possibly
exactly.
that can be the center facilitating the taking the technology to the rural area. Yes.
Sure. Thank you, Mr. Vimal.
Yeah.
Thank you for your nice presentation. Actually, I just want to know, actually, you might be knowing that we have already transferred the technology to two MSMEs. And also there are another 2, 3 companies who are interested. But before that, they want to do some market survey. So you have talked about your current ESSL program in Delhi. So in that program, you are only taking the electric cooking, or you want to also take some of the solar cooking also?
Yeah, thank you, Dr. Loha. And let me also highlight one fact. My company Finovista is impaneled with the CSIR headquarter level for all labs across India for transfer of your technology to the industry. So we are one of the agency which is have the MOU with your lab with the CSIR. That's number one. Number two, with the EESL, I am actually working in a multiple domain. So on the electric cooking, we are actually as a next program, we are funding for the electric cooking, especially for the electric pressure cooker. So that is already the project is approved and all, and we are going ahead. The current due diligence process is going on. Once it is done, we will be making it live, but definitely going to be there before March 2023. So that is the one. However, that there is the opportunity where your technology can be fit in the Ladakh pilot. We are actually looking for how to deploy the technology. At least we can show the pilot at the 5 households. So if 5 households can be fit, then ESL is ready to put their money and put the commercial model and all. And top of that, we are also working with the carbon finance, which you have highlighted. So carbon finance, we believe that this is going to be the beneficial for government as a non-subsidy model, making it further affordable. So a scale of operation, carbon finance, and the ESL model of demand aggregation can reduce the devices. So cost of devices. If the cost of devices become a negligible kind of thing, which is already happening in the terms of improved cook stove. Lot of carbon consulting firm is providing the free cook stove to the user, and they are recovering the money and making the money from the cook stove. We need a good entrepreneurs who can actually develop the good model in the carbon finance. So some of the speaker mentioned about that carbon finance benefit should also go to the user. EESL model, which we are actually talking to the providing the benefit to the user, and they have did with the LED bulb already. So LED bulb example can be replicated in the cooking.
So in that case, in your Ladakh program, how we can be associated? Means so to whom should I contact, or how will go ahead?
I will be writing a mail to Dr. Shankar. You know him, so and then I will be possibly facilitating the discussions and connections. So maybe like we can have the meeting and all with him.
Okay, okay. Thank you very much.
Thank you, Dr. Vimal. Thank you for this enriching discussion. So now is the time for the next presentation from our industry expert. Our next presenter is Mr. T.P. Yuvraj from GAIL India. Mr. Yuvraj holds Bachelor's of Engineering degree in Instrumentation and Control, Master's degree in Business Administration, and currently pursuing doctoral studies from IIT Delhi. He is working as a DGM in R&D department, GAIL India Limited, a public sector enterprise under Government of India. He has 20 years of rich experience in the areas of gas pipeline projects, gas pumping station operations and maintenance, solar PV power plant erection, commissioning and operation, instrumentation and electrical equipment maintenance. For the past 8 years, he is working in R&D department of GAIL in the areas of solar energy, fuel cells, unmanned aerial vehicle, robotics, sensors, thermoelectric generators, artificial intelligence, machine learning, corrosion, and cathodic protection. He holds 7 patents and he has published in many peer reviewed journals and conference papers. So, with this, I invite Mr. Yuvraj to start his presentation. Over to you, sir.
Yeah, good evening, and thanks for the introduction, Dr. Ishita. Is my screen and voice clear and visible?
Your voice is visible, it is audible, sir, but you need to share your screen.
Okay. Is my screen still visible or not yet?
Not yet.
Okay.
Yeah, now it is.
Okay. Yeah. So thanks to CMERI for inviting me to share my views in this forum. And thanks to Dr. Loha for the personal invitation. Um, my today's topic will be very short. Being the last presenter, I will keep it in 10 minutes. And the topic will be GAIL's roadmap to promote solar cooking system in rural India. So the outline will be So I will discuss about GAIL, what's his business portfolio. Many of you might be knowing, some of you may not be familiar with the GAIL's operation. So I will very quick upon the business segments and followed by Government of India's initiative on clean cooking mission and what is the GAIL's roadmap in this segment. So GAIL was born on 16th August 1984. We have our own mission and vision in place, and we have a very long business presence in the natural gas value chain, right from exploration in the top left corner to the transmission, LNG regasification, importing of LNG, and this production like LPG and final gas distribution. So okay, I'm feeling that crossed right from 1984 and 1987 we have built the country's biggest natural gas pipeline HPJ in 1987, and we have started our LPG business in 1990. We have entered into city gas distribution. We have started petrochemicals, that is production of polyethylene and plastics from natural gas, and we have started importing LNG through our Dahej terminal, and we have formed many joint ventures like BCPL and GAIL Gas. Followed by we have expanded our gas pipeline segments like DVPL, CJPL, Dabhol Bangalore pipeline, and recently under PM Urja Ganga pipeline, we have commissioned also Dobi Durgapur in the last year. So apart from that, we are one of the Maratona companies in India, and we got this coveted status in the year 2012-13. Yes, so having said that, we are now today integrated and diversified energy company. We have handling a natural gas pipeline of 14,000 kilometers approximately, and LPG pipeline dedicatedly for transporting LPG through the underground pipelines of 2,000 kilometers long. So we have also a gas sourcing portfolio. We are importing 29 million metric tons per annum of LNG, and we have a petrochemical plant at near Kanpur in UP and also in Assam in the northeast. So we have a huge city gas distribution network, and we have 10 joint ventures as a part of the energy conglomerate. We are also into exploration and production. We have 9 domestic blocks, 2 blocks in Myanmar and 1 in USA. We have the presence in outside the country in USA, Russia, Singapore, Myanmar, China, and Egypt. We have offices in the 4 cities. We have 6 processing plants, LPG and liquid hydrocarbon producing plants of capacity 3.8 metric tons per annum. And the last one is the transition we are taking place from fossil fuels to renewables. We have already installed 118 megawatt of wind power plant in the country, and we are also operating 12.26 megawatt of captive as well as the power producing power plants for the and injecting the power into the gas power grids. So this is the map showing our presence. This dark blue line and yellow lines are the pipelines being operated and it's in operation. The dotted ones are the under construction or is going to be shortly in operation in coming years. So this is our presence across the country with the liquid hydrocarbons, including the LPG production plants. And also we have 2 plants. So this yellow dots are the petrochemical manufacturing units. So we have a global presence, as I said earlier. We are operating 6 offices across the globe. So having said that, the last is about the company status. In the last financial year, our turnover was 91,426 crores, and the profit after tax is 10,364 crores. That is a strong balance sheet even can get. So coming to the main point, Government of India has already targeted to promote the clean cooking program in 25 crores of households in the country. So this is a target recently set by PMO office, and government has also asked the public sector like GAIL to promote this clean cooking mission to in an innovative way by developing the clean cooking system specifically for the rural applications. So when I talk about rural applications, I'm specifically talking about where areas where there is no LPG connection, yeah, even PNG connections, or the electricity options. So such areas are targeted. Still, there are several districts and towns and villages where the electricity has not reached. So we are targeting in these segments how to develop a clean cooking system to replace the conventional biomass based. Okay. So as you know, there were a lot of discussions in the previous presentations. So I will not go into the detail. If, of course, in simple, there are 2 routes. One is through solar concentration systems, wherein you can directly convert solar energy into heat. And the second option is through photovoltaics by converting first into electrical energy and then electrical to heat energy. So here, as Dr. Ravi also discussed about the third option of how to hybridize PV with heat storage. So that is an interesting area where we have also started working in this direction. So having said that, this is my last and the main slide where I'll discuss a little bit more about the GAIL's roadmap. This process has started. GAIL has initiated the Clean Cooking Mission program, and we have identified research groups across the country who are working in this area. And we have contacted 7 research groups across the country. We have discussed with them, and we have taken their background research works through publications and patents. And then and we have actually shortlisted one of the CSIR laboratory. And now the step 3 will be a detailed R&D project proposal will be obtained from the institute or the laboratory, which will be put up for the detailed review by our GAIL Research Advisory Council and GAIL management for taking it forward. So once it is done in an affirmative way, then we are going to shortly award the R&D project, which is the step 4. So what is the successful after completion of this R&D project? GAIL plans to take up for the technology development or a technology transfer to a startup company or industry partner who are willing to develop the solar cooking mission, especially for the rural India implementation. So lastly, GAIL will also be using the GAIL's startup funds to put in the money on equity-based investment for the development of the startup company who are willing to work in this area. So that's it from my side. And the step 1 and 2 are already almost over. So we are in the step 3 process. So this is what the GAIL's roadmap is. So we are targeting after the end of the 2 years from now, we are targeting somewhere around 1000 PV based solar cooking stoves or chullas to be developed and deployed in rural areas. So that's the target numbers we are working on, and that depends upon the success we are going to get in next 2 years. So we are hoping that there will be definitely a success, and we are looking to move forward. Thanks for your attention, and any questions I'm happy to handle.
Thank you, Mr. Yuvraj, for sharing Gale's roadmap for the promoting solar cooking technologies in India. So we will be taking the questions now.
Say Dr. Meenakshi Singh from CSIR. Very
Yes,
nice
ma'am.
presentation, Raji. Actually, I want to know this main focus is solar or electric, your mission.
Yeah. Our mission is to develop solar PV based cooking system.
No, solar based, solar energy or electric it is.
No, we are not targeting any electric system. We are going only for solar PV based
Okay,
cooking
that's
system.
what I want to know. Only for solar devices you are going to, and that you are
Yes.
going to deploy in the rural areas.
Yes.
Uh,
Particularly where there is no electricity and as well as no LPG connections.
okay, sure, sure, sure. That is cooking system only. You are going to develop
Sorry, ma'am.
cooking system.
Yeah, we are going to develop in collaboration with CSR lab, and it will be a collaborative research initially. Then it will be large scale development of the entire system along with the industry partners who are in this field, in the field of development of cooking systems. So we are going to bring in one more industry partner for a large scale deployment. This is our plan.
So our priority only on solar. Okay. Thank
Yes.
you. Thank you. Thank you.
Yeah.
Any more questions? So thank you, Mr. Yuvraj. Thank you for your presentation.
Thank you.
So with this, we come to the end of today's session on solar energy use for cooking. And we had quite an enriching experience and wonderful presentations over the past few hours. So it is my privilege to cast the vote of thanks at the end of the session. I would like to convey my heartfelt gratitude to the Ministry of Science and Technology and Ministry of Arts Sciences, the theme nodal director from ICGEB, the event coordinators from CSIR, and the organizers for providing us this wonderful platform. Thanks to Director CSIR CMERI, our institute in charge, and our colleagues for their priceless support. Thank you to all the dignitaries, speakers, participants, and attendees for this interactive session. Thank you to Dr. Meenakshi Singh from CSIR headquarters for actively participating in in these presentations and for your valuable suggestions, ma'am. Last but not the least, we would like to thank the technical team of iConnect who has helped us in coordinating this event very smoothly. Thank you all for making this event a success. We wish to have such fruitful conversations in the future also. Thank you.
Thank you all.
Yeah, thank you all. My
Very
special
well
thank to
organized.
all the speaker who has given their consent in spite of their busy schedule. So it was really a nice experience, and we hope that in future we'll work collaboratively to take this solar energy based cooking system forward in our country. Thank you all.
Thank you, Dr. Loha, Dr. Ishita, or everyone.
Thank you, ma'am.
Thank you.
Thank
Thank
you
you
very
all.
much. Thank you. Bye.
এক ঘন্টা ওদেরটা তো 5টা পর্যন্ত ছিল ওদেরটা চলছে
পার্থদা সত্যি বাবা হেড আইটি